Okay, good morning all. Right, so today we'll continue with the first we'll continue with maths. So then we'll move on to database and other topics. Okay, so today we'll do short sessions. Right, so last time we started discussing sets. So today we want to finish that discussion. So we discuss what is mean by a set. Set is a collection of elements having following properties. Every element must be unique, order must not be important, and of course it can be from any domain, and at the same time it must be very specific. So then we discuss the terminology, the notations like element, what is universal set, what is empty set. Okay, and so we discussed those things. So then we moved on to set operations. What is mean by intersection of two sets? What is mean by union of a set or union of two sets, and what is mean by complement and relative complement? Complement of a set, relative complement of set, or two sets actually, one set relative to another set. Right, so we have discussed those things. So then we moved on to cardinality of a set. Right, I think that is where we stopped. Let me double check. Okay. Yes. So we moved on to Cartesian product up to Cartesian product. Yes. Right. Intersection, union, complement, relative complement, XO, right, and Cartesian product. Right. So let's continue from that point onward and finish it today. Right. So the next sub-concept is joint sets versus disjoint sets. Two sets are said to be joined if there are at least one common element. If there's no such common elements, those are called disjoint sets. Sometimes we use the word mutually exclusive versus not mutually exclusive. But the simpler terms are disjoint, joint. And there's a small relationship. Number of elements in A union B, if it is disjoint sets, is NA plus NB. That is obvious. But if it is joint sets, number of elements in A union B is number of elements in A plus number of elements in B minus number of elements in A intersection B. That is obvious because this number of elements in the common area is double counted. Okay, double counted. So therefore you need to adjust it. So therefore we need to subtract it once. Okay, so you need to remember these things as well. Okay. Right. So next set of concepts that we're going to look at today are what is meant by subset, superset, proper subset, and proper superset. Okay, so again, you must be really serious about these things. Really, really serious. Okay, and you must be able to define them precisely. Pinpoint accuracy, what is subset, right? From mathematical terminologies, abstract terminologies. Right? What is mean by a subset? Now, if someone asks what is mean by subset, so you must have the world's best answer. Can someone tell me what is mean by subset according to your gut feeling? When do you say that A is a subset of B? So this is checking whether how clear your thinking is, how clear your communication is, and of course how clear your logical thinking is. Anyone? What is mean by A is a subset of B? Of course, there's nothing for this is the way to define it. As long as your answer is correct, that is fine. Anyone? What is mean by A is a subset of B? Now, if you can't answer this kind of a simple question, so that's not good for your personality, right? Your leadership. Anyone? What is mean by A is a subset of B? So I'm asking very simple question, right? Elements of A belong to both A and B. No. Elements of,
All the elements of A are also present in set B.
yeah. So that is a better answer. So the previous answer is correct, but it has unnecessary details. The answer in the chat. So if all the elements in A are also elements in B, we can say that A is a subset of B. Simple as that. Okay. So if you look at it from the other way, right, rather than saying A is a subset of B, we can say B is a superset of A. Okay. So then what is mean by a proper subset? So what is the difference between subset and proper subset? Anyone? So if you eliminate the possibility of A equal B, then we can say, so that means A is a subset of B, but A is not equal to B. So then we say it's a proper subset of B. And if you look at it from other side, B is a proper superset of A. Simple as that. Okay. Right. So this is how you write it in mathematical notation. A is a subset of B if and only if for all x is in A implies x is in B. So whenever element is in A, if it is always in B also, we say that A is a subset of B. So then how do you define A is a proper subset of B? So we write this and A is not equal to B. You can see? So you need to start thinking like mathematician, logician, engineer, and ultimately software IT professional, programmer. Okay.
The, one question.
Yes.
A equals B කියන්නේ A වල තියෙන ඔක්කොම elements සමාන නැහැ B වල තියෙන ඔක්කොම elements.
A
එහෙම
equal B
දෙපැත්ත
කියන්නේ A වල තියෙන elements ම තමයි B වලත් තියෙන්නේ කියන්නේ. හැබැයි if it is a proper subset, A and B can't be the same.
Okay.
Because this, according to this definition, whenever x belong to A, x must belong to B, there's a possibility that A and B are the same. But if you eliminate that possibility, that means at least one more element must be in B, which is not in A. So then we say A is a proper subset, right? So that means at least one additional element must be in B, which is not in A, to make it A is a proper subset of B. But if it is a subset, it can be same or lesser, but no additional elements in A. Okay, right. So small difference, but again, if you look at it from the other way, we call it superset and proper superset. Right. So these are very simple concept, but the thing is, are you serious? Right. If you're not serious in simple things, you will never be serious in complex things. Okay. Right. So these are some examples. Now you can clearly see that 4 is in A, 9 is in A, 12 is in A. So therefore, all the elements in B are also in A. So therefore, B is a subset of A. B is a subset of A. Or we can say A is a superset of B. And also you can see there are additional elements in A. So therefore, we can safely say B is a proper subset of A. And in other words, we can say A is a proper superset of B also. Because A and B are not the same. Okay. Right. So let's look at some properties of subsets. So these are very interesting properties as well, some of these. So the first property is empty set is a subset of any set. So that is an interesting property, right? So now you need to think abstract way. Don't just accept it, memorize it. see whether you can understand it. Empty set is a subset of a. Now you need to think something like a philosopher, right? Philosopher, because emptiness is a philosophical idea, conceptual idea, little bit fuzzy idea, not as simple as understanding one, two, half, right? Empty. So that is why a lot of religions also refer to this emptiness, right? Nivana kiyai, shunya kiyai, shunyatavade kiyai, right? So empty set means set having nothing, no elements. So we can say that nothing is all, because nothing can fit into anything, right? Nothing can fit into anywhere. So therefore, as a logic, we can say empty set is a subset of any set. It can be empty set or non-empty set. For empty set, if A is an empty set also, still it works because phi is equal to phi then. But we can't say phi is a proper subset of A, because if A is an empty set, then it doesn't work. But if A is not empty set, still we can say phi is a proper subset of A also. Okay. So the next one is, for any set A, it's a subset of its universal set. Its universal set, okay? Because when you consider the universal set, it must contain your sets, all your interested sets. So therefore, if A is your set and E is your selected universal set, if you have proper selected your universal set, definitely A must be a subset of E, right? So do you agree or you have doubts? Because if you have doubts, we can discuss. Right. So the next one is A is a subset of A. So if someone says A is a subset of A, do you agree? Or because you can either agree or you can say no, I don't agree with you. So I will agree with that person, because when we say subset, there's a possibility of equality, and we know that A is equal to A. So basically, A is a subset of A means A is a proper subset of A, or A equal A. Of course, this is not correct, but this is true. True or false is true. So therefore, this is true. Okay. Right. So the next one is, if A is a subset of A union B, and also B is a subset of A union B, that is again logical thinking, common sense. So this is my A and B. So this is my A union B. You can clearly see that A must be inside A union B. And not only that, B must be inside A union B. Right? Inside those same. It is same if A equal B, because that possibility is there, right? So therefore, we same equal mark is also valid. Okay. And similarly, we can say A intersection B is always a subset of A, and also A intersection B is always subset of B, because this part must be inside A as well as inside B, or equal. Okay, equal. So when you see something like this kind of a statement, you must be able to say exactly yes or no. ඔකට දන්න සමාජයේ සමහර මිනිස්සු කියන නෝන්ඩි වෙනවා. නෝන්ඩි වෙන්නේ ඇයි? ලොජිකලි කරෙක්ට් දෙයකට එයා කියලා ඉල්ලොජිකල් කියනවා. නැත්නම් ලොජිකලි ඉන්කරෙක්ට් එකකට එයා කියලා කරෙක්ට් කියනවා. ඔන්න ඒතර සමාජය තුළ යා බුද්ධිමත් මිනිස්සු අතර නෝන්ඩි වෙනවා. එයාගේ වගේම ලෙවල් එකේ ඉන්න එයාත් එක්ක ඉඳී. හැබැයි අනිත් අය අතර නෝන්ඩි වෙනවා. මොකද අනිත් අය දන්නවා මේක ලොජිකලි වැරදි. ඒක වළක්ව ගන්න හොඳම වැඩේ තමයි improve your logical thinking. එතකොට සමාජය ඇතුළට ගිහිල්ලා විහිළු වෙන්නේ නැහැ එක එක වෙලාවල්. Can you explain the first one? So first one means this one. So I told you it's a philosophical thing. You need to think. Because nothing can fit into anything. Right? Nothing can fit into anything. Right? So therefore we can say that if we have set A, inside this set A, empty set can be fitted. It's a philosophical thing. Not only I can say if empty set is a subset of A, I can say empty set is a subset of A complement also. Because empty set can fit into this area as well. So that is something you need to think. Okay? Because it's sort of a philosophical or abstract thinking you need to use. Or you must come up with a contradiction to this. Saying that in this kind of scenario, this concept is false. This statement is false. So then we can discuss. Right. Next one. If A is a subset of B and B is a subset of C, then obviously A is a subset of C. Right? So if A is inside B and B is inside C, so definitely A is inside C. Okay. And if it is a proper subset, then we can say A is a proper subset of C. So what about this? A equal B if and only if A is a subset of B and B is a subset of A. If someone says A is a subset of B and B is a subset of A, definitely A must be equal to B. Otherwise, so that can't be satisfied, right? A ගේ ඇතුලේ B ඉන්නත් ඕන, B ගේ ඇතුලේ A ඉන්නත් ඕන. ඇතුලේ හෝ සමානව. එතකොට ඇතුලේ ඉන්න බෑනේ. එහෙනම් මෙතන සමාන ලක්ෂණයක් හොයලා තියෙනවා. So that means definitely A equal B. Right? Or else you need to come up with a contradictory situation saying that in this kind of a situation, this statement is false. So then we can discuss. Okay? Because these are sort of axioms. So why it's difficult to prove it? Because those are very simple axioms. Axioms you are not supposed to prove, right? You are supposed ප්‍රත්‍යක්ෂ කරගන්නවා. Right? So සමහරවිට rule එකක් කියලා කියන ප්‍රත්‍යක්ෂ වල. මේක ඔයා ප්‍රත්‍යක්ෂ කරගන්න ඕනේ නැත්නම් ඔයා මේකට contradiction එකක් හොයාගන්න ඕනේ. එතකොට අපිට කතා කරන්න පුළුවන්. Right? So next one is interesting one. If A is a subset of B, then B complement is a subset of A complement. Not A complement is a subset of B complement. Right? So A is inside B. Then A complement, this is A complement, is inside. So this is B complement. So this is B complement. So B complement is inside what? B complement is inside A complement. So every element in A complement is an element in B complement. So therefore, B complement, every element in B complement is an element in A complement. So therefore, B complement is a subset of A complement. Right? So you can see A direction here subset is A, here subset is not A complement, B complement. Okay. Right. So those are some interesting properties. So in the exam paper, sometimes they will give this kind of statements and ask, set of a statements and ask which of these statements are true. Sometimes they will say which of these statements are necessarily true. Sometimes they will ask which of these statements can be true. So different questions. Can be true means at least there's one possibility. Necessarily true means it must be always true. Okay, so you will get to know about these words when we start doing past papers. Right, so next question is, next concept is power set. So it's super simple concept. Power set of a set is a set containing all the subsets. So if you have a set like this, if you write all the subsets as elements and create a new set, it's a set of sets. Then we say we have the power set of the original set. Okay. Right, so let's take an example. Say this is my set. So I want the power set of A. Power set of A is denoted by PA. Here P doesn't mean probability, so we use for different meaning. Power set of A. So now you need to write all the subset of this. Remember the two special cases. Empty set is a subset of any set. So therefore, when someone asks you to write subsets of a set, always include the empty set. And set itself is also included because subset means itself can also be a subset. And then all the other combinations where you have at least one less. Say 1 only, 2 only, 3 only, 1 and 2, 1 and 3, 2 and 3. That's it. And if you have 1 and 1 comma 2, you can't write 2 comma 1 because then those are the two same things. Because in sets, order is not important. So the moment you write something like that, so that means it's not a set basically. Your big one is not a set because these two are the same. Okay. So therefore, don't write duplicate elements. And if your set has n number of elements, your power set will have 2 to the power n number of elements. So when you have 3 number of elements, your power set has 2 to the power 3 or 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. If your set has 4 elements, your power set will have 2 to the power 4 or 16 elements, which includes itself and empty set. Okay. Right. So that is power set. Right. So let's do an exercise, small exercise. So which of the following sets are equal? First one, yes or no, equal or not? Anyone? X such that X is a natural number and X is between 1 and 5. That is A. B, 2, 3, 4. Are they the same sets or different sets? So those are same sets because natural numbers between 1 to 5 is 2, 3, 4. Right, next one. Next one. X such that X is a real number and X is between 1 and 5. B is 2, 3, 4, 5. So clearly those two are not the same because between 1 and 5, how many elements can be there? Anyone? How many real numbers can be there between 1 and 5? Anyone? How many real numbers can be there between 1 and 5? So I'm asking question.
3.
Huh?
3.
Not 3. How many real numbers are between 1 and 5? Yes, infinite number of
Sorry, infinity.
infinite number of elements. So this is a finite set. So therefore, definitely these are not the same. Right. Third one, X such that X is a day in a week. So day in a week means Sunday, Monday, etc. And B set says Monday, Sunday, Saturday, Tuesday, Wednesday, Thursday, Friday. And obviously those two are the same because this explains the possible days. Okay. Right. State whether following sets are finite sets or infinite sets or not a set. So there are three possible answers. Finite set, infinite set, not a set. What about the first one? First one. You have three possible answers. Yes, first one is a infinite.
set.
Okay, infinite set. Second one?
Not a set.
Why do you say it's not a set?
Because it's not well defined.
So when we say stars in the universe, it's not well defined. Why do you say it's not well defined?
Not atomic.
Sorry?
It's not atomic.
Do you think that sets must be atomic? The universe means where we live. It's a concept, right? Concept that we have defined. Of course, it has no boundaries, but we can define concepts without boundaries. So you don't.
It's an infinite set.
It's an infinite set. Because universe is infinite, obviously the stars are also infinite, right? Because at least for now, if one day if we find the boundaries of the universe, maybe the stars in the universe will also be a finite set. But according to our current knowledge, right? So this is an infinite set. As long as we have defined what is universe and what is a star. Right? In general, it's an infinite set. Right. Third one, X such that X is a student in a session. Say this particular session or particular session. Number of students in a particular, say, Zoom session.
Finite.
It's a finite set. Right. Last one. X is sequence of natural numbers start from 1 to 5.
Finite.
What is mean by sequence? Single can was sequence. Sequence. Anukram. Natural numbers start from 1, ends with 5. That is 1, 2, 3, 4, 5. In that order. Sequence has order. Sequence has order. Sequence and series both having order. So after one,
It's not a set.
it's not a set because it's emphasized on the order. The moment it emphasizes on the order, it's not a set because it's a sequence. So sequences are not sets, definitely. Any sequence is not a set because sequence has an order. It's not a set. Right. So do this. Take a piece of paper and do this. Of course, you can't talk about that. So this clearly, if you can shade it correctly, these things correctly, your logical thinking is good. But if you are shaky, if you are not very sure, or if you shade wrong areas, that means definitely you have some room to improve. That you need to double check. That means definitely your sets knowledge is understanding about sets. The thinking behind sets is little bit not up to the expectation. Right? Take a piece of paper and shade it. If you want, you can attach it to the chat, but it's okay. At least keep it with you. You can be honest to yourself. Because some students, they can't shade these. Sometimes they are very shaky also. අත් දෙකත් වෙනුන සමහරුන්ගේ මේක අත් ඒ කියන්නේ logical thinking out. එයාට තාම and එක o එක මීටර වෙලා නැහැ. අපි හිතනවා අපිට and එක o එක හරියම ලේසි කියලා නෑ. සමහරුන්ට එහෙම ලේසි නෑ. and එක o එක තේරෙන්නේම නෑ. not කියන එක තේරෙන්නේම නෑ. එක්ක තේරෙන්නේ නැහැ එක්ක trust කරන්නේ නැහැ. confidence කියන එකත් වැදගත්. හරි ඉතින් මාව trust කරන්න ඕනේ. මේ question එක exercise එකේ තියෙන statement එක exam එකේ question එක trust නොකර ගිහලා paper එක ලියන්න බෑ නේද? examiner සැක කරන. So don't doubt this statement. Take the statement as it is and shade it. Right. So let's see. So it must not belong to A. So this is a general scenario. Always go for the general scenarios, not for the very specific cases. So it must not belong to A. That is something like not belong to A. Then may A not belong to A ko mata වේගුලන්න බෑ. චණ්ඩිය වගේ පාඩ කරන්න. At the same time, it must not belong to B. සමහරුන්ගේ අත වේගුලන not belong to B කියව ගම. වෙනේ හොල්මන් ඔලුවට එනවා. ඒ කියන්නේ ඔලුවේ හොල්මන්. Now intersection. Intersection means both yellow and black lines must be there. Both the yellow and black lines are somewhere here. Because here only black lines, here only yellow lines, here neither. So this is the area. And this is the area. Okay. Outside A union B. Outside A union B. Okay. That is your final answer. Right, do the second one. මේවා ලේසි වෙන්න පුළුවන් සමහරවට. හරි කමන්නේ ඒක කරා. එකක්වත් අරද්දන්න දුක. A minus B complement. මේ one shot කරන්නේ එකක්වත් වරද්දක් නැහැ කියලා හිතේ තියාගන්න. So you must have high standards in your life. Like a surgeon. Surgeon කෙනෙක්ගේ standard එක high වෙන්න ඕනේ. එයා දෙනවා මම එක operation එකක්වත් වරද්දන්නේ නැහැ. අපි හිතමු eye surgeon කෙනෙක් කියලා නැත්නම් එක මිනිස්සේ පොට්ටෙක් වෙනවනේ. හැප්පෙන්නේ නැති වෙනවා. So that is why අපි කියන්නේ medical college ගන්නකොට ඒ තුනක් මදි. තවත් filter කරන්න. Perfect කරලා ගන්න. Set high standards. So then that is called total quality. So everything you do is of high quality then. A minus B complement. So that means belong to A. Right? Belong to A. From there you need to eliminate not belong to B. It must belong to A. At the same time, it must not belong to B. So what is it? Not belong to B. Not belong to B is this. I just don't not belong to B now. So from belong to A, I need to eliminate, from red side, I need to eliminate black. Right? From red, I need to eliminate black. So then what I get is this yellow. So this is belong to A. From belong to A, I have eliminate not belong to B. So then I get this. So it's same as A intersection B. Okay, A intersection B. Okay. So how many of you guys got the correct answer? Okay. Right. Next one. So do this. A complement union B complement. If you can straight away draw, I don't mind. But if you straight away draw, make sure you don't make mistakes. Okay. Not belong to A union, not belong to B. So union means either this line, no that line, no both line. Intersection means both lines. Right, so I will draw A complement. Right. Pretty draw, right? Now by name hard karana. That is A complement. Okay. So now I will draw B complement. B complement. Not belong to B. So then union means red line, no blue line, no both. So red line, no blue line, no both is anything outside the intersection. Anything outside the intersection is answer. Only thing is the intersection part must not be shaded. So that is your final answer. Okay. So if you get that, so that means you are very clear about your logic. Anything outside the intersection. Right. So do this one. So these are super important. Don't take this lightly, because if you are not good at logic, right, all the other problems start. But if you are good at logic, a lot of problems are root causes are resolved. මෙතන ප්‍රශ්න තියෙනකොට ගොඩක් ප්‍රශ්න ජීවිතේ ප්‍රශ්න අහනකොට ජීවිතේ ලොජිකල් තින්කින් නැහැ. A minus B intersection B. So intersection means both. Okay. And do it fast. Otherwise, you will come home and say, time is not enough. No, time is not enough. We are not efficient enough. Your thinking is not efficient. Yeah. Hari ඔතෑනි නේද? බොහොම ලඳ බොළඳ කෙනෙක්. So A minus B means belong to A but not belong to B. Intersection B. So intersection means you must have both blue and red lines. There's no such area, so therefore answer is 5. So your final shading must have nothing. Okay, so therefore answer is empty set. It's empty sets. Okay. Right. So assume that A, B, and C are sets. Right? That means there are 3 sets. Shade the area A minus C in a Venn diagram. කල්පනාවෙන් කරන්න. You must start with these 3 sets. Now shade A minus C. Anyone want to shade it in my screen? කැමති කෙනෙක්ට පුළුවන් මගේ screen එකේ අන්තිම උත්තරේ shade කරලා දෙන්න. A minus C. What is A minus C? So you forget about B because you don't care about B. Right? Then B අමතක කරලා වැඩේ කරන්න. So belong to A but not belong to C. Belong to A but not belong to C. So that is this. You don't care about B. B is not relevant to you. So therefore, just simply forget about B and show A minus C. A minus C. Okay, so that is the area. So there's explanation saying color set A and common with B, not common with C. So that is true. The color set A and common with B. A and common with B क्यों मैं बतेना? Your wordings are wrong. Set A and common with B. I don't know what you mean by. Maybe you should have mentioned it as color set A. Color set A කිව්වම මුළු A කියන set එකම පාට කරන්න වෙනවා. Therefore, maybe you think of explaining, but your explanation is really not correct. Your explanation is not really correct. Okay. So it's a very good exercise if you guys can do. Say one person. So අපි මේ වගේ area එකක් දීලා එයාට explain කරන්න කියන අනිත් එක්කනට එයාට පේන්නේ නැහැ ඔයාගේ රූපේ. I think this kind of a games were there in sometimes back, I think in Sirius or what somewhere. So you are supposed to explain it. You are supposed to explain it. One way is you write this kind of a statement, right? A minus C. If you don't use the set not terminology, somehow you need to explain it. එතකොට ඔයාලට තේරෙයි ඔයා කියන එක නෙමෙයි අරයා තේරුම් ගන්න. එක්ක ඔයා කියන එක වැරදි එක්ක ඔයාලට තේරෙන්නේ නැහැ. හරි? එක්ක ඔයාලට තේරෙන්නේ නැහැ. එතකොට ඔයාලට තේරෙයි මේ කොච්චර precise වෙන්න ඕනද කියලා අපි දෙන්නම. එක්කෙනෙක් precise වෙලා මදි. හරි? උදාහරණයක් විදිහට ඔයාලට පුළුවන් මෙන්න මේක explain කරන්න. අනිත් එක්කෙනා දැකලා නැහැ බින්දුව. So how do you explain it? Within maybe 1 minute. අනිත් එකෙන් දීලා තියෙන මෙන්න මේ diagram එක විතරයි. එතකොට තේරෙයි communication වල තියෙන රංගේ. කොච්චර වැදගත්ද communicate කරද්දි කියලා. හරියට communicate කරන්න. right. එයා sets දන්නවා නම් ඔයාලට මේක ලේසියෙන් explain කරන්න. sets දන්නේ නැත්නම් ඒත් පුළුවන් වෙන්න ඕනේ. සාමාන්‍ය වචන පාවිච්චි කරලා හැබැයි එයා හරියට කරනවා. දෙන්නගේ so then the both guys have the responsibility to be very precise. මෙයාට precisely කියන්න ඕන අනිත් එක්කෙනා කියන එක precisely තේරුම් ගන්න. right. Exercise 8. Shade the area A union B union C complement. Okay. So this is my ABC. So this is my A. This is my B. Then I need C complement. C complement. So C complement I will draw in blue. C complement. Okay. Right. So union means this line no, that line no, other line. That means either blue or black or red. That area must be there. So that means everywhere other than this area. Everywhere other than this area. So that is your final area. If you got it, so that means you are done. Right? You have understood it. But if you are still shaky, that means still you are a little bit not sure about what is union, what is intersection. Okay. Right, do the 9th one. A intersection B, union A intersection C, union B intersection C. Now, when the problem is getting complicated, so you need to think like blocks now. So that is how you manage complexity, engineering. So this is very easy actually. Right. Time is enough because you can't take infinite time. A intersection B is this. A intersection C is this. Then B intersection C is this. So union means either red line, no blue line, no yellow line, no all any combination. So the final answer is then this. Anything inside this. Make homework again. Right. So that is your final shaded area. Right. So now we move on to algebra of sets. Okay. So algebra of sets is set of rules, or sometimes we can call them axioms, which are true. Which are true. And you have already done these things under computer system, so therefore I will do it faster. Okay. Right. So there are about closer to 20 rules. Okay. But the good news is sets has duality principle. So if a rule is there, its dual is there. So therefore, though we say it's closer to 20, it's ultimately it's about closer to 10, 10, 12, because not every rule has a dual. Okay. Right. So let's take, so these are the basic rules. Of course, there are some more rules, but these are the most widely used rules that you must know. Right. How many? Pairs 1, 2, 3, 4, 5, 6, 7, 8, 9. That means 18, 19, 20. Right. We will look at only 20 rules. We will look at only 20 rules. It doesn't mean that there are only 20 rules. There are a few more, but we will only look at 20 rules. So these are the 20 rules. And most of the time, those are dual. So therefore, when you know one rule, actually you know two rules. Okay. So these rules you must naturally remember. I'm not asking you to memorize these. If you like the subject of sets and logic, and if you feel like the subject of sets and logic is the most important subject in this world for you, you will naturally remember. So this is more important than periodic table. This is more important than, right? So any other thing that you have memorized. Okay. So this is the most important thing, because from the moment you get up until you sleep, what you do? What you do? From the moment you get up until you get into sleep again, what do you think? What do you do? Think. What do you mean by thinking? What do you mean by thinking? Right now also you think. What do you mean by thinking? Can someone explain what is mean by think? They නැගිටලා ඉඳලා නිදන් සමහර නිින්දෙනුත් හිතන. එතකොට හීන පේ. එතනත් මේ හිතන එක නවතින්නේ නැහැ සමහරලාට. එතනත් ඔන්න හීනක් දකින්න වෙනවා. ඒත් logic. So what is mean by thinking? Think කරනවා කියන්නේ අපි දෙකයි කරන්නේ. එකක් we recall past things and we plan the future. How do you do that? We need some data, information, right? And we put some logic. ඔන්නක දැන් හිතනවා කියලා කරන්නේ. දැන් මම ගෙදර යනවා, ගෙදර යනකොට මොනවද තියෙයිද? ගෙදර ගියාට පස්සේ මම මොකද කරන්නේ? ගෙදර මෙහෙම වුණොත් මෙහෙම කරනවා. හරි. මේ මුනේ නැත්තම් මෙහෙම කරනවා. අම්මා මේ යතුරත් අරන් ගිහලා තියුණොත් මම මෙහෙම කරනවා. යතුර ගෙදර කට්ටිය හිටියොත් මට ඒ ප්‍රශ්නේ නෑ කියනවා. දැන් ලොජික් හිතන්න. Logic with some facts, data. So therefore, thinking is something we do all the time. එතකොට හිතනකොට දන්නේ නැතුව හිතනවාද සහ හෝ එහෙම වුණොත් එහෙම උනේ නැත්තම් ඒක තමයි මේ කරන්නේ. ඒක හරියට පටලව ගත්තට පස්සේ පටලව ගත්තේ නැත්තම් හොඳයි. ඒක කාටද අයියෝ ඒක ඔබ්වියස් නෑ ඕන තරම් මිනිස්සු පටලව ගන්න. මිනිස්සු කරන ගොංකම් ප්‍රමාණය දවසකට සීමාවක් නැත. හරි. ඔයා හරියට ලොජික් ඉගෙන ගත්තට පස්සේ ඔයාලට පුළුවන් කොලයක් අරගෙන කවුරු හරි උදේ ඉඳලා හරි උදේ 8 ඉඳලා 10 වෙනකන් කරපු ගොංකම් ප්‍රමාණය ලිස්ට් එකක් ලියලා දෙන්න යාට. ලොජික් දාන්න කෙනෙක්ට පුළුවන්. ඔයා කියන්නේ මෙන්න ඉල්ලොජිකල් වැඩක් කරා, මෙන්න ඉල්ලොජිකල් වැඩක් කරා, මෙන්න ගොම් වැඩක් කරා, මෙන්න මීහරක් වැඩක් කරා කියලා වට ලියන්න පුළුවන්. හැබැයි අර මිනිස්සයා ඔක්කොම කරන්නේ ලොජිකල් කියලා. උන්නක තමයි වාසිය ලොජික් ඉගෙන ගත්ත එක. අනුන්ගේ ලිස්ට් හොයන්න යන්න එපා. ඉස්සෙල්ලා තමන්ගේ ලිස්ට් එක ක්ලීන් කරගන්න. අනුන්ගේ දේවල් හොයනවට වැඩිය හොඳයි තමන් හැදෙන එක. එතකොට හොයාගන්නවා උදේ ඉඳලා කරන ගොම්කම් ප්‍රමාණය මෙච්චරයි. ඊළඟ දවසේල ගොම්කම් ප්‍රමාණය අඩු කරනවා. එතකොට වට තේරෙයි අනේ මගේ ජීවිතය හරි රිලැක්ස්, සුන්දරයි. මට ඕන තරම් දැන් කාලය තියෙනවා. ඒ ගොම්කම් කරන ඒවා නවත්තනවනේ. ඉල්ලොජිකල් දේවල් ටික නවත්තන්න දාන්න. එතකොට ඔයාලට හරි රිලැක්ස් සමහරවිට හරි කාලයක් නෑ අනේ වැඩක් කරන්න වෙලාවක් නෑ ඒ ගොංකම් කරන හින්දා ඒ වැඩක් කරන්න වෙලාවක් නෑ ගොංකම් කරන ඒකට වෙලාවක් නෑ තමයි අප්පෝ අපේ මිනිස්සුන්ට දින වෙලාවක් නේ අපේ මිනිස්සු මාසෙකට කීපාරක් අවුරුද්දකට කීපාරක් ට්‍රිප් එකක් යනවා විනෝද වෙන ඕගොල්ලෝ හිතන්න වෙන රටවල මිනිස්සු රටවල් වල සංචාරය කරනවා සංචාරකයෝ කියලා අපේ මිනිස්සු හැබැයි අපේ මිනිස්සු මාසෙකට කීපාරක් වෙඩින් වලට යනවා මලකවල් වලට යනවා බණකවල් වලට යනවා කොටහළු ගෙවල් වලට යනවා මලකවල් වල නිදි කිර ඉන්නවා සතුටෙන් ඉන්නේ අනිත් මිනිස්සු හොටෙල් එකක වෙන රටක සතුට වෙනවා බලන්න ඒක ලොජිකල්ද ඒ නිදි කරපු එකෙන් ඇති වැඩේ මොකද්ද මලකේද කල්පනා කරලා බලන්න කල්පනා කරලා බලන්න. සෝබන වැඩවලින් තමයි තියෙන මාසි මොනවද කියලා. සෝබන වැඩවලින් ප්‍රදර්ශනාත්මක වැඩවලින්. It's a logic ඉගෙන ගන්න හැබැයි yeah. Right, so let's take one by one. දොර කාටට කරනවා මේ අපේ සංස්කෘතික අංග. හරි. අපි යුතුයකම් ඉටුකම්. කමන්නේ. යුතුයකමක් වෙනවද මරණයට පස්සේ මිනිහ ගාවෙන් ඉන්න එක. පුළුවන් නම් මැරෙන්න කලින් ගිහිල්ලා පෙහෙතක් කරන් දෙන්න නාවන්න අන්න යුතුයකම් right so the first rule complement of a set is the same set do you agree say this is my set A so therefore this is my A complement so then what is the meaning of complement of A complement not belong to this set but belong to E. That is again this. That is my A. So therefore, yes, complement of a set is the set itself. So that is your rule number one. Okay. It doesn't have a dual. Right. Second rule. Of course, you can learn it in any order. So this is how we have organized it. Second rule says A intersection B is same as B intersection A. So that is axiom, obvious. Because whether you start from with A and then B or B and then A, anyway the common section is common. So therefore it doesn't matter whether we say A intersection B or B intersection A, it's the same thing we are talking. It's something like it doesn't matter whether we say 5 into 3 or 3 into 5. It's the same. So if you feel like this is obviously yes, so then this is also obviously yes. But don't take it because I am telling it. You think about it. Okay, you think about it. Right. So its dual is A union B same as B union A. Again, ultimately what you get is this common, sorry, not common, this area belong to A or belong to B. Whether you start from A side and come to B or B side and come to A. So therefore we can safely say Or if you see A union B, you can replace it with B union A, or B union A can be replaced with A union, because in sense, both are the same. Right. So now we'll move on to our next dual, next pair, ඊළඟ dual. A intersection B intersection C is same as A intersection B intersection C. Or we can simply say A intersection B intersection C, because this bracket is not important. So therefore, sometimes we simply say it is A intersection B intersection C. Because ultimately what you get is this, whether you start with A intersection B, this is A intersection B, and then you intersect with C. Here we start with B intersection C, that is this, and then you intersect with this, but ultimately what you get is this. Right? And its dual rule is A union B union C is same as A union B union C. Ultimately what you get is this yellow area. Okay. So therefore, again, this bracket has no real meaning. So you can just get rid of the bracket and say A union B union C. Okay. Right. So the next one, next dual, Joe dual. This is the first one. This is the second one. A intersection B union C is same as A intersection B union A intersection C. This is something like කියන්නේ සමානයි කියන එක නේ. මෙතනත් වෙන්නේ මේ වගේ වැඩක් හරි. That is something like, say, 5 into 3 plus 4 is same as 5 into 3 plus 5 into 4. 4 plus 3 is 7. 7 into 5 is 35. 5 into 3 is 15. And 5 into 4 is 20. 20 plus 15 is also 35. Okay. So this is also something like making sulu A intersection B union A intersection C. Right. Again, this is not true because of that mathematical thing. Those are just coincidence. They're just similarities. So you shade this one. Right. So this is B union C. Then this is A. So then where do we have both lines? Both lines are here. So then A intersection B, that is red lines. A intersection C, that is these indigo lines. And it is union. This line, no, that line, no, both. Yeah, that is again this. You can see both are the same. So therefore, this is same as this in sense. And its dual is, how do you create the dual? So if a rule is correct, its dual is also correct. So how do you create the dual rule? Actually, if a rule is correct, its dual is also correct. It doesn't mean that both are the same rules. So that means when there's a rule, there's another rule. Okay. So how do you make the dual? Intersection become union. Union become intersection. Right? E become phi. Phi become E. Don't touch complement. Okay. So if you do that, you get the dual. Now this intersection become union. Union become intersection. Intersection become union. Union become intersection. Intersection become union. So therefore, dual is A union B intersection C is A union B intersection A union C. So that is your dual. You can see. And again, shade the left-hand side, shade the right-hand side, you will get the same area, this yellow area. That's something you must do. Right. So the next dual pair. So we call this De Morgan law, De Morgan rule. Right. This is true for any number of sets. This is only for 2 sets, but it's true for any number of sets. That is A intersection B intersection C intersection D intersection. Its complement is A complement union, B complement union, C complement union, D complement union, and so on. Okay, so that is the first form. Its dual form is A union B complement is A complement intersection B complement, or you can extend it to any number of sets. Again, shade the left-hand side, everything other than A intersection B, that is A intersection B complement. Right-hand side, A complement union B complement. So red line, no, green line, no, both. So that is again everything other than this intersection. So therefore, Both are the same. And similarly, you can prove the dual of that, the De Morgan rule. So what you get is this outside white area or the yellow area in left side or right side. Right. So our next rule is A intersection A is A. So that is obvious, right? ඔක්කොම obvious තමයි මේ ඔක්කොම axioms, right? අපි ඇඳලා බැලුවම තමයි obvious කියලා පේන්නේ. So this is my A intersection again A. So intersection is also A. So therefore if you see anywhere A intersection A, you can replace it with A. ඒක හරියට අර පහ වැඩි කිරීම එක තියෙන තැනක පහයි කියලා ලියනවා වගේ. ඔයාලට බය නැතුව මේක අයින් කරලා A කියලා ලියන්න පුළුවන්. In a sets expression related to a set. Its dual is, of course, it change intersection to union. A union A is also A. A union A is also A. Right, so now we'll move on to our next dual. Now we play A with A, then we can play A with A complement. A intersection A complement is 5. So that is obvious, right? Belong to A and it must belong to A at the same time, not belong to A. So there's nothing like that. So therefore it's 5. So its dual is A union A complement is E. Remember 5 become E. A union A complement is E. So belong to A or not belong to A. That is everything. So there's a famous statement, something like this by Shakespeare. Can someone tell me what is that statement? Remember, Shakespeare is also English person, right? I told you these logic sets, concepts were mainly built by British people, English people. When De Morgan, Boolean. So there's a British author, Shakespeare. එයාගේ තියෙන ඔය වගේ A union A complement වල ළඟින් යන ප්‍රසිද්ධ statement එක. චූටි statement එක. වචන දෙක තුන. Can anyone tell me? Anyone? කෙනෙක් කතා නැහැ. චූටි statement එක මහා ලොකු දෙයක් නෙමෙයි. නෑ every action has a reaction කිව්වේ Shakespeare නෙමෙයි නේද නිව්ටන් නේ. මම මේ කතා කරන්නේ මේ පොත් ලියපු කෙනෙක් ගැන. අපි නිකන් සර්ච් කරපුවම Shakespeare's popular quotes කියලා සමහර විට එයි. සමහර විට මට 100% කියන්න බෑ. ස්පෙලිං වැරදුනට කමක් නැහැ. මේකේ to be or not to be. තේනවා. පළවෙනියටම ඒක තමයි. Some of the most popular quotes from Shakespeare include to be or not to be. Not to be or not to be කියන්නේ මොකද්ද? To be කියන්නේ වෙනවා. Not to be කියන්නේ වෙන්නේ නැහැ. එක්ක ඒට අයිති වෙනවා එක්ක ඒට අයිති වෙන්නේ නැහැ. Okay. වෙනවද මේගොල්ලෝ හරි ලොජිකල් කට්ටිය කියලා. දැන් අපේ පොත්වල දිනව නෙමෙයි නේද අපේ සාහිත්‍යකාරයන්. දැන් වෙනවද ඊළඟ එක? There is nothing either good or bad. Nothing either good or bad කියන්නේ මොකක්ද? මේ බැලුවමඩ වෙන මේක ලොජික් එකක් කියන්නේ නේද? Nothing either good or bad. ඒක කිව්ව මොකක්ද? දැන් ඔයාලා දැන් ඔන්න හතරම අරන් ගහගෙන කල්පනා කරන මේ මොකක්ද එක්ක මේ ෂේක්ස්පියර් කියන්නේ කියලා. මොකද මේගොල්ලෝ ආශ්‍රය කරේ බූලියන්ලා වෙන්ලා නේද? ඒගොල්ලෝ අනිත් සමාජයේ හිටියේ යුනිවර්සිටි වල. මොකද්ද මේ nothing either good or bad කියන්නේ? So this is good. This is bad. Either good or bad කියන්නේ මේක. either good or bad. Nothing either good or bad කියන්නවත්. මෙහෙම ඒවා නෑලු. මෙහෙම ඒවා නෑ කියනවද? ඔක්කොම තියෙන්නේ ගුඩුත් නොවන බෑඩුත් නොවන දේවල්. දැන් ඉතින් ඒක සාහිත්‍ය කල්පනා කරලා හරි මේක ලොජික් මේක මැත්ස් නෙමෙයි. එයා කියන හදන කතන්දරේ. Right, so let's move on. So therefore, A intersection A complement is 5. A union A complement is E because it's everything. To be or not to be. Okay. To be or not to be. එහෙමද? බලාගෙන කලිසමත් උස්සගෙන සුද්ධ වෙයිලා. මොකද ලංකාවේ මිනිස්සුන්ට දීලා තියෙන චින්තනය මේ අපෙන් ඔක්කොම හොරකම් කරන් ගියා කියලා. හරි බලාගෙන කලිසමත් උස්සන් සුද්ධ වෙයිලා. හරි. පප්පලගේ සීයලගේ ආච්චිලගේ වරන් ගියා නේද? ඒ තමන්ගේ දින නොහැකියාව වහගන්න කියන කතන්දර. හරි අපෙන් තමයි ප්ලේන් එක උස්සන් ගියේ අපෙන් තමයි නේද? ඉන්ටෙල් ප්‍රොසෙස් එකත් අපෙන් එන්නේ නැති නේ. හරිද? අපේ මිනිස්සු තාම අර සුරේ කියලා දාගෙන ඉන්නේ. ඕකෙන් තමයි මේ ඕකෙන් තමයි මේක මම දැන් කියන කතාවක් හරි. ඕකෙන් තමයි අර ඉන්ටෙල් ප්‍රොසෙස් එක ඇදුවේ ඒගොල්ලෝ. හරි? හොරකම් කරන් ගිහිල්ලා. අපේ කුරුම් බැට්ටි මැෂින් අරන් ගිහලා තමයි ඒගොල්ලෝ කැටපිලර් එක ඇදුවේ. ඔව්. correct. ඔව් ඒ කාලේම තමයි කරලා තියෙන්නේ. ඔක්කොම අපේ අය හොරකම් කරන් ගිහලා අමුඩ ඉඳලා ගලවන් ගිහිල්ලා. හරි? ඒකයි මේ අපිට කෙලවුනේ නේ. වෙන අවුලක් උනේ නැහැ අපිට වෙන කිසිම අවුලක් නැහැ අපි එලකිරිත් ලොජිකල් තින්කින් පොරවල් හරි ඔක්කොම අපේ ටික ගලවගෙන ගියා right so that is your opinion right so, okay you can have your own opinions right so the next one A union E is E right? Is it correct belong to A or belong to E that is belong to A or belong to E. Or means this line no, that line no, both. This line no, that line no, both is what? Again E. So therefore, when you see A union E, you can replace it with E. You can replace it with E. Okay. Right. So what is the dual of that? Union become intersection. E become phi. So the dual is A intersection phi equal phi. A intersection phi is equal phi. Is it correct? Belong to A, right? Belong to A and belong to nothing. What is the result? Nothing. Can someone explain this? Can someone explain this? Can someone explain in simple English why is it correct? Why this statement is correct? Simple English. Why is it A intersection phi is phi?
Because nothing belongs to phi.
Nothing belongs to phi. Okay, that is a statement is correct, but that is not, you are not giving the reasoning for this one. You need to justify this statement. Nothing belong to phi can be nothing and phi are same concept to two notations. You need to combine that statement with another statement and build the answer. You have not built the answer. You have just given me the part of the answer. You need to fill that.
A intersection phi means
Right, I will draw. A intersection phi means
belong to A
belong to A
intersection with null set.
okay null set. So then So I know that A intersection 5 means A intersection null set. Yes, I know that. My
Null set belongs to A set A.
null set belongs to set A. Okay, so then how do you say that A intersection 5 is 5?
හැම සෙට් එකකටම නල් සෙට් එක එලිමන්ට් එකක් වගේ තියෙන නිසා නල් සෙට් එක සෙපරේට්ලි ගවුවාම කොමන් වෙන්නේ නල්.
I can. Even can what?
හැම සෙට් එකකටම නල් සෙට් එක තියෙනවා කොමන්.
හරි ඒක null set එක මේ A කියන set එක ඇතුලේ තියෙනවා. හරි.
ඔව්.
හරි.
එතකොට ඒක සෙපරේට්ලි නල් එකත් එක්ක කොමන් ගත්තාම වෙන්නේ නල් එක තමයි කොමන්.
separate null එකත් එක්ක common ගත්තම null එක තමයි common. හරි. I think වටින් කොටින් ඒකත් පිළිගන්න වෙනවා මට. පිළිගන්න වෙනවා මට. But you can explain it much simpler, right? ඊට වැඩි සරලව කියන්න පුළුවන් නේද? What is the meaning of intersection? මට සරලව එකිනෙක මොකක්ද මේ intersection කියන වචනේ තේරුම? එතනින් පටන් ගත්තා නම් මේක සරලව කියන්න පුළුවන්. What is the meaning of intersection? In sets? දැන් පාරේ කියා ගන්න බැරි. In sets terminology, what is the meaning of intersection? I am not asking technical questions. Simple explanation. Intersection means
Both.
Between.
common. Right? Common. Intersection කියන්නේ මොකද්ද? දෙකටම තියෙන්න ඕන common. Right? So A intersection 5 means common to A and 5. But 5 has nothing. So when this has nothing, there can't be any common element because common means belong to both, but this has nothing. So that means common to A and 5 is also nothing because this one is nothing. This one has nothing. I think that could have been a simpler explanation. Right? So you stick with the basics of definition. Intersection means common, but this one has nothing. So then there can't be any common things because this other one has nothing. So when something has nothing, one set is having nothing, so there can't be common with that, right? So that common is also nothing. So therefore, yes, A intersection 5 is 5. So therefore, if you see A intersection 5, you can replace it with 5, right? You can replace it with 5, okay? Right, so then its dual is A intersection E is A. So that is very easy. So this is my A, and this is my E. So intersection means common or both lines. So both lines are, you can clearly see that it is in A. So therefore, if you see A intersection E, you can simply replace it with A. Right? Simply replace it with A. ඒක හරියට නිකන් පහ වැඩි කිරීම එක තියෙන දැනට වල පහයි කියලා දාලා යනවා. ඒ වගේ ඒකයි මේක අතර සම්බන්ධයක් නෑ. ඒ වගේ. Right. So next one is A union 5 is A. How do you explain that? A union 5. Union means what? Belong to. So X union Y means what? Belong to X or belong to Y. But here nothing. That means belong to A or belong to this nothing. So therefore nothing is added to A because belong to A or belong to this nothing. So therefore nothing more to add. So therefore it is A. Likewise, try to explain it in a very simple way and see whether can I make it even simpler? Can I make it even simpler? Right? So your best answer is the simplest answer. So එහෙම කිව්ව මම නෙමෙයි කවුද? Einstein. Okay. So Einstein තරම් සරලත්වය ගැන කතා කරපු කවුරුත් මම හිතන්නේ නැහැ කියලා. හැබැයි Einstein වැඩ කරේ මොන එකද? ලෝකේ තියෙන සංකීර්ණම දේවල් එක්ක වැඩ කරේ. හරි. එකක් තමයි මොකද්ද? සාපේක්ෂතාවාදය. හැබැයි Einstein තරම් සරල බව ගැන කතා කරපු මිනිස්සෙක් තවත් නැහැ. So if you cannot explain it simply, if you cannot explain it simply, you don't understand it well enough. කවුද කිව්වේ? Einstein නා මම නෙමෙයි. with Einstein. ඊළඟට එකක් තව එකක් තමයි මොකද්ද? When the solution is simple, right? God is answering. Albert Einstein. හරි. software develop කරද්දී හොඳට මතක තියාගන්න. හරි. Einstein මං හිතන්නේ යුදෙව්වෙක් නේද? යුදෙව්වෙක්. ඒතකොට ඒගොල්ලෝ දෙවියන් වහන්සේ විශ්වාස කරානේ. ඒකන්ද එයා දෙවියන් වහන්සේ විශ්වාස කරාද නැද්ද කියන එක වෙනම ඩිබේට් එකක්. එයා ඒ ගැන වෙනම කතා කරලා තියෙනවා ආගම් ගැන. හරි. ඒතකොට එයා සංස්කෘතිකව යුදෙව්වෙක් හන්ද එයා ඒ වචනේ පාවිච්චි කරනවා. හරි. එයා කියනවා when the solution is simple, God is answering. හරි. ඔයා the problems of the software develop කරගෙන යනවා කියන්නේ. හරි. දැන් finally ගියාම project software develop කරනවා. job එකකට ගියොත් එම software IT පැත්තෙන් ඔයාලට software develop කරන්න. හැබැයි සමහරවිට ඔයාලට solution එක develop කරලා යද්දි තේරෙනවා අපෝ ඊට වඩා simple විදිහට මේක කරන්න පුළුවන් කියලා. So therefore what is the best solution? Best solution is the simplest solution. So the best answer is also the simplest answer. නැත්තම් ඔයාගේ කැලරි වියදම් වෙනවා. නේද? වචන එහාට දානවා මෙහාට දානවා අනිත් අතට දානවා. හැබැයි ඔයාලට සරලව මේ කියා ගන්න පුළුවන් කියන්නේ එළම කිරි. ඔයාටත් හොඳයි අහන එක්කනටත් හොඳයි. මොන හරි කරද්දිත් එහෙමයි හොඳම විසඳුම තමයි මොකද්ද? සරලම විසඳුම. සරලම විසඳුම. ඔබ දැන් ලෝකේ යනවා ඉස්සරහට මොඩර්නයිසේෂන්. මොඩර්නයිසේෂන් එකේ එක කොටසක් තමයි මොකද්ද? සරල කරගෙන යනවා. හරි. එතකොට අතීතයේ ජීවත් වෙන මිනිස්සු අතීතකාමී මිනිස්සු ඉන්නවානේ. අතීතයේ තමයි හොඳ දැන් ඉස්සරහා කාලකන්ණි ඉස්සරහා ලෝක විනාශ වෙනවා. මිනිසුන්ගේ ආයුෂ අඩු වෙනවා. හරි කිය නේද? පරිසර දූෂණය වෙනවා මිනිස්සු මැරෙනවා කියලා නේද? හැබැයි අන්තිමට මිනිසුන්ගේ ආයු අපේක්ෂා බලනවා වැඩි වෙගෙන යනවා. නේද? දැන් පහුගිය දවස්වල මම දැක්කා මේ ලංකාවේ කාන්තාවගේ ආයු අපේක්ෂාව තව අවුරුදු 5කින් කොහෙද වැඩි වෙලා කියලා. හැබැයි බැඳගෙන අහන් ඉන්නේ මොකද්ද? ලෝකේ ඉන්නේ ආයුෂ කෙටි වෙනවා. හරි? ඕවා තමයි අහන් ඉන්නේ. බැඳගෙන. හැබැයි දත් එක්ක බලුවම 1900 ඉඳලා බලුවට පස්සේ අපේ මිනිසුන්ගේ ජීවිතය ආයුෂ වැඩි වෙගෙන යනවා. මොඩර්නයිසේෂන් එක කොටසක් තමයි අපි සරල වෙන්නේ. ගේ දොර ඉඳලා කරන වැඩවල ඉඳලා හරි ඉඩකට මේ උපකරණ වල ඉඳලා හැමදේම සරල කරගෙන යනවා. වෙබ්සයිට් එකක් උනත් අපි සරල කරගෙන යනවා. ඒක හොඳම උත්තරේ තමයි මොකද්ද? simplest answer. හොඳම solution එක simplest solution. හරි simplest solution. So try to get into that mood, that mindset of a modern man, right? Modern man who appreciates simplicity. ඒ ඔයගලන්ට මේ උගන්වන්න බෑ. ඔයගලන්ට මේ උගන්වන්නේ නැහැ ඉස්කෝලේදී. ඉස්කෝලේදී ටීචර් තමයි සාරිය ගලව ගන්න බැරුණා. නේද? සරල ඇඳුමකට යන්න බැරුණා නේද? ඒගොල්ලන්ට පුළුවන් නූතනත්වය ගැන උගන්වන්න. සරලත්වය ගැන උගන්වන්න. ඒගොල්ලන්ට ඒක කරන්න බෑ. Impossible. ඉතින් තමන් සරල වෙලා ඉන්න බෑ. Right, so the next one. A exclusive of B is same as A intersection B complement union B intersection A complement. So that is again obvious because those are axioms. But හැමදේම obvious කියන වචන තමයි කියන්නේ මොකද ප්‍රත්‍යක්ෂනේ. Right. So what is mean by A exclusive of B? That is this by definition. And you can see that belong to A and not belong to B. That is this part. That is A minus B or A intersection B complete. So this is belong to B and not belong. And if you take the union, that is exclusive of. That is another one. Up your computer system वल करेगा कौन A exclusive of B is A dot B bar plus B dot A bar किया. एक आगे उतरी तमाम. Right. So the next one. A union A intersection B is A. ඔකද අපි කිව්වේ A plus AB is A කියලා නේ. So A union A intersection B belong to A union belong to A and B. That is again A. So therefore we say A union A intersection B is A, or in dot plus notation digital circuits we wrote it like A plus AB is A. And this is one of the most widely used statement that you used in semester 1. These things are not new to you, right? අපි එතකොටත් මේක කතා කරා. Right, so the next one is A union A complement intersection B is A union B. That again you can shade it and find out. Why we are interested in this? Because in digital circuits we use it as A plus A bar B is A plus B. මෙතන පොඩි typing mistake එකක් තියෙනවා A plus B වෙනවා. මෙතනත් වරද්දලා තියෙනවා. හරි. මෙන්න මෙතන පොඩ්ඩක් වරද්දලා තියෙනවා. හදලා අප්ලෝඩ් කරන්න නා. So this is මම හිතන්නේ කලින් එකේ එහෙමම දාලාද. This is a A not belong to A and B දෙක හරි. මෙන්න මෙතන තමයි වරද්දලා තියෙන්නේ. හරි. Let me fix it, otherwise I will forget it. So this මේ කලින් එකේ තිබිච්ච එක එහෙම copy කරලා තියෙනවා. හරි ඒකයි ඒක වෙලා තියෙන්නේ. Now it's correct. I will upload the new PDF, okay, with that fix. Right, so that's it. That's it. Okay. Right, පොඩි paper එකේ තියෙන question දෙකක් කරලිමු. Because we are done with sets. Next time we can do few more questions and do past papers and do start logic. Because we are going to do these 3 papers all together, I will take a little bit older one because ඒවා අපි වෙනම කරන්න නැති හින්දා. Right, do the question number 8. දැන් මේ පැය දෙකක් ඇතුළත කරන්න ඕන හරි paper එක. Do the question number 8. Multiple answers are possible. This 2018. Now you must think super fast. At the same time, 100% logical. So this slash is another symbol for minus. Slash කියන්නේ minus වලට තියෙන අනිත් symbol එක. Therefore slash means minus. So take a piece of paper and shade it. You need to draw 5 Venn diagrams. Right? So roughly you get about 40 questions in 2 hours. You get about 3 minutes. But the logic question වලට වීඩියෝ වැඩි වෙලා යනවා. සාමාන්‍ය set question තමයි අඩුවෙන් වෙලා යන questions. So හිතා ගන්න පුළුවන් අඩුවෙන් වෙලා යන question එකකට කොච්චර වෙලා යනවද කියලා. Quickly do it. So how effective your logical thinking is, how efficient your logical thinking is. So you check whether your logical thinking is effective and efficient. That means you are productive in logical thinking. Okay, right. First one. මට දැන් මේක 5 පාරක් අදින්නවා. ඉතින් වෙන කරන්න දෙයක් නැහැ. මම මිනිස්සෙක්නේ. A intersection, B complement. Say this is A, this is B, this is C. So A intersection B, this is C. A intersection C, this is C. A intersection D, this is D. A intersection E, this is E. A intersection F, this is G. A intersection H, this is H. A intersection I, this is I. A intersection J, this is J. A intersection K, this is K. A intersection L, this is L. A intersection M, this is M. A intersection N, this is N. A intersection O, this is O. A intersection P, this is P. A intersection Q, this is Q. A intersection R, this is R. A intersection S, this is S. A intersection T, this is T. A intersection U, this is U. A intersection V, this is V. A intersection W, this is W. A intersection Z, this is Z. A intersection Z, this is Z. A intersection Z, this is Z. A intersection H, this is H. A intersection I, this is I. A intersection J, this is J. A intersection K, this is K. A intersection L, this is L. A intersection M, this is M. A intersection N, this is N. A intersection O, this is O. A intersection P, A intersection B complement means everything outside this. Everything outside this. Okay. From that, I need to subtract or eliminate A intersection B intersection C. එතකොට එළිය තියෙන ඔක්කොගෙම මම අයින් කරනවා මෙන්න මේ කොටස. Right? So that means from all these things I eliminate this one that is not definitely this. ඒක මේක වෙන්න බෑ. So I will say no. Okay. Right, next one. A complement that is not belong to A. Not belong to A. Outside this. Okay. Intersection. Right, intersection. So the moment we say intersection, that means it must include outside this. Right? Because A complement is outside this. So, but this answer has this part. So my answer must have it, may have anything outside, but not inside. But this answer has inside. So therefore this can't be the answer. Next one. Intersection A. So that means it must belong to A. Yes, this one also inside A. So therefore, so far, so good. Intersection B union C complement. That means outside B union C. It must not belong to anything outside this. Right? Okay, but it must belong to A. It must belong to A. Right? It must belong to A and it must not belong to B union C. So that means this part. But this is not this part. So therefore I would say no. Okay. බලන්න මම වැරද්දවද කියලා. It must belong to A. එතකොට හරි. හැබැයි එයා ඊට අමතරව B union C ට අයිති නැති වෙන්න ඕන. B union C ට අයිති නැති වෙන්න ඕන කියන්නේ මේකෙන් එළියේ ඉන්න ඕන. So මෙයා එළියේ නෙමෙයිනේ. Right. So next one. A intersection B intersection C complement. That means anything outside this. Anything outside this. Right? From there you subtract A intersection C. A intersection C is this. That can't be. ඒකත් වෙන්න බෑ. දැන් ඉතුරුලා තියෙන්නේ මෙයා විතරයි. A intersection C. A intersection C is this is A, this is C. So that means this part. That is A intersection C. From there you subtract common area. This part is eliminated. Now you got this. This is an answer. For me, only answer is C. Right? Only answer is C. Right? So let's double check the answer. Question number 8. Only answer is C. දැන් තේරෙනවද වැඩේ? ඔන්න ඔකට ලෑස්ති වෙන්න. දැන් තේරෙන්න ඕන කොච්චර වේගෙන් හිතන්න ඕනද කියලා. හරි ඈලි මෑලි දුබලි ගතියින් ඉඳලා මේ විභාග පාස් වෙන්න බෑ. එහෙම වෙන්න බෑ. එහෙම අයට IT කරන්නත් එපා. Okay. Right. So do this question number 9. Sets A, B, and C such that B is not equal to C and A minus B is equal to B, A minus C. Which of the following these are true? ඔන්න බලන්න logic. තියෙනවද කියලා බලන්න. මම කියනවා තනිකර බලන්න logic පුළුවන්ද කියලා. Okay, anyone got the answer? The sets A, B, and C are such that B is not equal to C. A minus B is same as A minus C. Okay, so let's try to draw this. A, B, C. A minus B belong to A but not belong to B. That is this part. It is same as A minus C. Belong to A but not belong to C. Okay, so let me copy this question. Let's draw it again. It looks a tough question. A, B, C. A minus B. A minus B means belong to A but not belong to B. Okay. Belong to A but not belong to B. A minus. And A minus C. A minus C means belong to A but not belong to C. Belong to A but not belong to C. That is this. And those are the, and it says they are the same. They are the same means red area and blue area are the same. Red area and blue area are the same means this must be 5, right? So this must be 5. And this must also be 5, right? And when the pain is not so that means if it is common to A and B, it is common to C also. No, not common to C. Not common to C. A minus B is same as A minus C means B is not equal to C also. How to do this one? It's a real tough one. So this must be 5, this must be 5, otherwise these can't be the same. This must be 5, this must be 5 means still this can be there, right? B is not equal to C. B is not equal to C. Same as A minus C. They draw it correctly. A minus B belong to A but not belong to B. Correct, right? A minus C belong to A but correct. Shaded area is correct. Since these two are the same, this and this must be empty. But this this may have data, right? This may have data. These are empty, but still this can have data. How to do that? Anyone has an idea? I'm running out of ideas now. How can I get something from this? B is not equal to C. Which of the following are true? A equal to B. I don't think that is correct anyway. A intersection B is equal to A intersection B is this equal to A intersection C. That is this. I think this is correct because these are empty. So therefore A intersection B must be same as A intersection C. Right? Because A intersection B is what? This area, yellow area. Okay. Yellow area is not yellow.
So could you explain why those two areas are empty?
Because it says A intersection A minus B is A. So now I have shaded A minus B. Okay, let me do it again. Let me undo this. I can't undo also. Let me delete. Right, so this red area is what? Red area is belong to A but not belong to B. Okay. This green area is belong to A but not belong to C. So I have removed this part. And if now this is green area. So this says green area is same as red area. Green area is same as red area if here we have the red but not green. So then this area must have no element. And this area must also have no element. Then only red area has the same elements as green area. Can you get that as a logic?
Yes, sir.
Yes, right. Because if there's at least one element here, the statement becomes false. So that is why I took it like that. If I go by this statement, right? So this is correct, right? Then A intersection B. A intersection B means this, but this must be empty. So therefore A intersection B become this. And your A intersection C also become this. So therefore, if this is correct, this must be correct. So therefore, I'll go for B. But what about the others? Right? So therefore, your A intersection B must be same as A intersection C. Because already we know that these two are 5. Okay? Because A intersection B is this. A intersection C is also this. A equals C, I don't think. From that, we can't get it like that. I can't think of anything else. I don't know whether these are correct, right or wrong, but I can't relate. Only thing I can relate is this. So therefore, for the safe side, I will go for B. I don't know whether there's another answer, but I feel like B is correct according to this. Okay, anyway, let's see what is the answer. It's a very tough one for me anyway. 2018, question number 9. Oh, B, C, D. 3 answers are there. B, C, D. B, C, D. Anyway, B is the correct answer. So that means I get 1/3. But what about C and D? C says A intersection C. A intersection C is now this one. A intersection C is inside B. So may වැඩියෙන් නම් එහෙම තමයි. But can we also say that it's always correct? Yes, now our A intersection is actually this one because these are empty. Right? Yeah, correct, right? So if my A intersection is actually A intersection B intersection C. So therefore A intersection C must be inside B. Because what we got from here is my A intersection B is same as A intersection C, which is same as A intersection B intersection C. So therefore, A intersection C must be, because my A intersection C is A intersection B intersection C, so therefore it must be inside B. Yes, this is correct. Actually, I missed that. And same logic, we can say A intersection B, right? A intersection B is actually A intersection B intersection C. It must also be within C. Because from this we derive that A intersection B is same as A intersection C, which is same as A intersection B intersection C, because these are 5. From that we can derive that this is correct, this is correct, this is correct. But these are not relevant to that. Anyway, it's a very tough one. I somehow managed to get 1, but I never look at these 2. Okay, seriously. But actually those 2 are also correct. By the way, it's a tough question. Okay, so don't worry that all your questions are tough like this. Very rarely you get this kind of a tough questions. Okay, shall we do one more question? Right. So let's do the 7th one. Maths. Let A and B be 2 distinct non-empty sets. So non-empty, distinct. That means A is not equal to B. Distinct, non-empty. Both A and B are not 5. And their A is not equal to B. Okay. So that means either they talk about this kind of scenario or they talk about this kind of scenario. So definitely A is not equal to B. So this is not the case. No. But these are possible. And none of these are empty. And you need to find false statements, right? False. It was an rectangular true ticket mark.
Sir, second sample like ඒකයි බේකයි කොමන් වුණේ කොහොමද distinct වෙනකොට?
A and B, 2 distinct. What is mean by distinct?
distinct කියන්නේ unique වෙන්න ඕන.
Set එකද unique වෙන්න ඕන elements. Set එක.
Sets.
ඉතින් මේ set එක unique නැද්ද? A set එකයි B set එකයි unique නැද්ද? Set එකක් විදිහට මම හදලා තියෙනවා elements නෙමෙයි. මෙතන හරි. මේ කියන්නේ set එක element ගැන නෙමෙයි. ඒක මම කියන්නේ. I think you need to consider both scenarios. So your task is check whether this is false for both scenarios. මෙහෙම වුණත් මේක false වෙන්න ඕනේ මෙහෙම වුණා. මොකද මේ දෙකේ එකක් වෙන්න පුළුවන්. ඒකම දෙකම ඇන්දේ නැත්නම් වට සමහර එකකින් ඔයා තීරණයක් ගන්නවා. Are false can necessarily false, because true වෙන්නම බෑ. Right? Which of the following are false?
So third example if there's subset එකක් ගන්න පුළුවන්.
This one. මේකද? ඔව් නේද? ඒකත් ඇත්ත තමයි. දැන් තමයි ඒකත් මට ඔළුවට ආවේ. Yes, because then also non-distinct. මෙහෙම වෙන්න පුළුවන් තමයි. A and B. So then again distinct non-empty. හැබැයි අනිත් පැත්තට ගන්න පුළුවන් ඒතකොට. B is inside A. ඔන්න තව scenario එකක් එනවා එතකොට. So that's a good pick. B, yeah, those are also possible. Now we have 4 possibilities actually. Actually, I missed those 2. Now here U means universal set, okay? මේගොල්ලෝ ගොඩක් අය E කියලා පාවිච්චි කරනවා U කියලා පාවිච්චි කරනවා. ගොඩක් අය උඩ කියලා ඇති. right? මෙතන නම් කියලා නෑ U කියන්නේ මොකද්ද කියලා. So just remember U is another symbol they use for universal set. Right? Sometimes they use Z, sometimes they use U. Right? What are your answers? It's a tough one. ඔක්කොම tough තමයි බලාගෙන යන්නේ. Right. I will take the obvious first. So what about E complement? E complement is 5. That is a rule. E complement is 5 can have a rule එකක්. Because E is universal set. We are not interested anything outside that. So therefore anything outside universal set is empty for us because we are not interested. So therefore this is anyway, this is one of our standard rule. ඒකෙන් තමයි not true is false, not false is true කියන එක ගත්තේ අපි මතකද? So therefore this is definitely true. අපි true එක mark කරන්න යා. This is true. So then මේ mark නොකරන ඒවා දැන් හරියනවා. So what is 5 complement? Anyone, what is 5 complement? U complement is 5, 5 complement is E. So this says A is a subset of E. Not A is a subset of E. E is a subset of A. A කියන එක E ගේ subset හරි නේද? A is a subset of E because when E is your universal set, A must be always inside D. So therefore this is also true. දැන් මට true ඒවා දෙකක් හම්බුනේ. Okay. A is a subset of E. 5 complement is C. Right. Those are true. What about this? A is a proper subset of A. That can never be. Because A is A. Proper subset means A cannot be A. Right? What is meant by X is a proper subset of Y? X must be inside Y and X can't be Y. එහෙම වෙන්න බෑ. Right? So therefore this is definitely false. ඔන්න අපිට ඒක උත්තරයක් ආවා දැන්. Right? So then what about this? A is a subset of A intersection B. Right? So දැන් කොට ඔන්න හතරම බලන්න පුළුවන්. Here A intersection B is this. A is a subset of A intersection B? No. Actually A intersection B is a subset of A. Not A is a subset of A intersection B. මෙතනදී ඒක වෙන්න බෑ. මෙතනදී A is this. Is it a subset of A intersection B? No. A intersection B is an empty set. එතනදී false. හතරෙන්දී මොනවද? Is A a subset of A intersection B? මෙතනදී ඕනේ. So you can see A is a subset of A intersection B. මෙතනදී false, මෙතනදී false, then මෙතනදී true වෙනවා. Right? Because A is inside A intersection B. If A, because distinct. මේ කියන්නේ සමාන වෙන්න ඕන නැත්නම් ඇතුලේ තියෙනවා. So therefore this is false. Sorry, this is true. ඒ කියන්නේ මේක මේ අවස්ථාව දෙකේ false. මේ අවස්ථාවේ true වෙනවා. So that means this is not answer. Because not always false. Sometimes false, sometimes true. So what about this? A is a subset of A union B. මෙතනදී වැරදි, මෙතනදී හරි. A is a subset of A union B. Sometimes true, sometimes false. Right? So what is always false? Always false is this one. A cannot be inside A intersection B. So therefore this is always false for B. Therefore I go for C. Okay. Anyway, it's a tricky question. බලමු උත්තරේ හරියද කියලා ඉස්සෙල්ලා 7. C හරි හැබැයි B ත් අරගෙන තියෙනවා. ඒ කොහොමද B ගත්තේ? හරිනේ මෙයා උත්තරයනේ. මෙයා උත්තරයක් කියලා මාක් කරේ නේද? A can't be a proper subset of A. Yes, B is definitely an answer. B is definitely answer because A can't be a proper subset of A. Yes, A can't be a proper subset of A. කොහොමද? Yes, B is a definite answer. මම ඉස්සර මාක් කරගත්තා. මේකත් වැරදි නේද? A is a subset of A intersection B. මෙතනදී වෙන්න බෑ. හැබැයි මෙතනදී වෙන්න පුළුවන් නේ හැබැයි. මෙතනදී වෙන්නත් බෑ. මෙතනදී A equal A intersection. හැබැයි මෙතනදී වෙන්න පුළුවන් නේ. So you can see A is a subset of A intersection B. A intersection B is this. And this is your A. So here it can be true. So therefore, actually the answer must be B. C is not an answer. Right? Examiner has taken C also as an answer. හැබැයි මේක නොවෙන්නත් මේක වෙන්නත් පුළුවන් මේ වගේ සිටුේෂන් එක. So therefore still I will say my answer is B, not B and C, but examiner has taken both B and C. හරි අපි නිකවට මේක chat GPT එකට දාලා බලමු. හරි actually my answer is only B. Right, my answer is only B. So I delete because I want to copy paste this. Right, let me copy this. So examiner's answer is B and C, my answer is B. Let's see, maybe examiner is correct, or maybe it's a debatable answer. So remember, my answer is B, okay? Examiner's answer is B and C. ChatGPT says B, C, and D. Yeah, ඊටත් වැඩි හම්බ කරන්න. කොහොම බලන්න. B is false, හරි ඒක හරි. A true කියප එකත් හරි. C. This is false in general. In general එයා අරන් තියෙන්නේ. ඒක තමයි අවුල. හරි. In general තමයි අරන් තියෙන්නේ. In general false කියන එක හරි. හැබැයි සමහරවිට මේක වරදින්න පුළුවන්. U complement. මේ U කියලා අරන් තියෙන universal set එකද? මල කෙලිය. So I took U as U is universal set, correct. So U complement is 5. So this is true name. මේ කොහොමද කරන්නේ? Should be empty. But in general, it's not always the case. I always not case කියන්න බෑ. Anyway, it's fuzzy answer. ChatGPT is also giving another answer. So ChatGPT මේක in general හරි කියලා අරගෙන නැහැ. U complement is 5. අපි මේක දෙමුද Gemini-ටත්? Gemini. Because we get 3 different answers. Me, examiner, and ChatGPT. Gemini දාමන හරි එකක් ඒක ගන්න. Because its question is a little bit fuzzy, the wording, the way someone interpret the word false. Answer to the question is C කියලා තමයි යා කියන්නේ. අන්න එයාත් හැබැයි examiner එක නෑ. එයා ඊට C විතරයි කියලා කියනවා. දැන් හතර දෙනාට උත්තර හතරක් ආවා යා. Right? So Gemini says only C. I say only B. Examiner says B and C. ChatGPT says B, C and D. අපි ඔබට නවත්තලා දාමු. තව එක්කෙනෙක් තව මොන හරි කියයි. I think the question is too fuzzy. Too fuzzy. Whether you take it as general answer or you look at all the possibilities. Okay, උත්තර වෙනස් වෙන්නේ. හරි? මොනවාද උත්තර වෙනස් වෙන්නේ? Right. So now you can see things are getting more interesting, challenging. Right? So anyway, don't worry. Not every question is like that, but it looks like this paper is a little bit fuzzy paper. Okay. Right. So we'll take a break. After the break, we'll move on to database. Right. So now it's 10. We'll start at 10:15. Okay, so let's continue with database. Okay. Right, so now we have finished sets. Okay, so we need to do a few more past paper questions, but the theory part is over. Okay. Right, so today we want to start relational data model, second part, database. Okay. Right, relational data. Last time we finished introduction to databases. Right, so data analysis and ER modeling. So this is related to send the syllabus. Syllabus is already available in Google Classroom, right? So you should be able to download it from Google Classroom, right? Semester 2. So every subject syllabus is available in Google Classroom. So this is a database syllabus. Okay. Right. So let's move on to this topic 2. Data analysis and ER modeling. So remember when we develop a software, remember database is part of the software. We go through problem definition, requirement analysis, design, development, testing, and then of course evolution and maintenance. Okay. So problem definition, requirement analysis. So part of the requirement analysis under structured programming is analyze the data related requirements. So the result is conceptual data model or conceptual ER diagram. So this is what we are going to do today. So then this will be an input to designing. And design has two phases, logical design and physical design. So the physical design, the result is logical data model with normalization and so on. So then we go for the physical design with selected technology like Oracle, MySQL. So you need to fine tune your logical ER model to match the technology. And also physical design includes indexes and optimization. So then you develop it, your database, creating tables, relationships, and so on. Then of course the deployment as part of deploying of the software, testing, and so on. Okay. Fine. So therefore, what we are doing right now is something related to requirement analysis. Understand the data related requirements and model it. The result is conceptual ER model. That is a big picture. Right. So in conceptual data model, so these are the terminology we use. The concept called entity, attribute, relationships. So those are the major concepts. Okay. Major concepts. So then in the designing stage, we will talk about tables, relationships, primary keys, foreign keys, and so on. That is something afterwards. So that is when you come up with a design ER diagram. Okay. And there are some other ER models as well, like object data models, if you're supporting object-oriented concepts, extended ER diagram, that is ER diagram, normal relational ER diagram with support to the object-oriented concepts. So object data model is pure object-oriented data model. Okay. So then some other aspects like self-describing data models are there based on XML, key value stores, and so on. But those are very special cases. We are not interested in those things. Okay. But those are mentioned in your UCSC not. Okay. And then low-level physical data models, that is when you go to the physical design, data types, field widths, and that kind of more details are there. Your index, what is the type of index, right? Is it a bitmap index, hash index, tree index? So those things are there in physical data models. But we are not going to discuss about those things. We are only interested in this topic, conceptual, the business or the conceptual ER model. Okay. A conceptual ER modeling. So this is part of the requirement modeling. So we analyze the requirements, okay, gather, analyze, and then model. So this is the result of modeling the data aspects. So we will model the major entities and their attributes and the relationship between those entities. Simple as that. And remember, this diagram is during analysis, so therefore we make it non-technical and we make sure that it can be understood by a non-technical person like customer, like manager or someone who is not very familiar with technology, because this is requirement analysis. So we should be able to show it to the customer and verify. And also later, of course, this will become the input to your design. Your software design team will take this as input. So therefore, this is for both technical and non-technical people. So therefore, it's not difficult. Obviously, if non-technical person should be able to understand your ER diagram, it should be simple diagram, right? But you should know your concepts and draw it properly, right? Draw it properly, model it properly, right? So let's take one by one. Entities and attributes. So what is an entity? Entity is anything that we are interested. A major concept that we are interested, like employee, department, project. It depends on the domain. Sometimes entity is called entity set. Okay, entity set. But in general, we say entity. So your entity can be living physical thing, like student, employee, customer. Can be a non-living physical thing like machine, product, vehicle. Or it can be a conceptual entity like payment, course, order, account, and so on. Right. So what are the things that we are interested about entities? So we are interested whether it's a strong entity or weak entity. And also we are interested about what are the attributes and what kind of attributes those are. So let's take one by one. So we can identify two types of entities. So whenever you identify entity, you must identify what kind of entity is that. Is it a strong entity or is it a weak entity? So strong entity, or sometimes we just call it an entity, is a major concept. It's a normal major concept in our domain, our problem area. If it is student management system, maybe student, course. So those are strong entities, major concepts. So then we have something called weak entity. Weak entity is an entity which on its own we don't care much. But because it's related to some of our major entity or strong entity, anyway we need it. Okay, so that means we are interested in that entity because it depends on one of our strong entity. On its own, we don't care much, but anyway we are interested because we need those data as well, details as well. Okay, but not directly related to our business or domain. For example, if you take spouse of an employee, it's a weak entity. If you are developing an employee management system, obviously employee, department, projects, those are strong entities. But maybe you are interested in the spouse of an employee, or maybe because spouse also can claim insurance. So when someone claims insurance, we must have already having those details. Otherwise, there can be frauds. So likewise, indirectly, we need those details. So therefore, we model that entity also. So then it's a weak entity. The student management system, student, course, teachers, strong entities. Maybe you model students' parents as well, because maybe we need to contact someone in case of emergency, but not a major concept for our system because we don't teach to parents. So then we say parent is a weak entity. So with your experience, you will identify whether it's a strong entity or weak entity. Okay. So this is how you model. Strong entities are modeled as normal rectangular shape, whereas weak entities, we use double square rectangular shape. So it clearly shows it's a weak entity, indirect entity, not directly related to us, our system. And when you name entities, make sure you use a singular noun, like employee. Don't call it employees. Don't call it vehicles. Just the convention is use a singular noun. Okay? Noun. Right. So then we are interested in the attributes of entity. So attributes are the properties of an entity, like salary of an employee, name of an employee, date of birth of an employee. Employee is entity, salary and blah, blah, blah are attributes. So attributes are represented by elliptical shapes. And we give a descriptive noun like age, name. Okay. So these are some examples of attributes. And we can classify attributes also. What is known as identifier attribute, stored versus derived attribute, composite attribute, multi-valued attributes, and so on. And these are the normal attributes. Okay. So what is mean by identifier attribute? So identifier attribute is a special attribute in an entity which we can use it to uniquely identify a record. If we can use a particular attribute to uniquely identify a record, instance of the entity, we call it an identifier attribute and we underline that attribute. You can have one or more identifier attributes. Sometimes there can be multiple identifiers like employee ID and both NIC, ID card number. So then later we will decide which one is selected as a primary key, but you can mark multiple identifiers and sometimes the identifier can be composite as well. So then stored versus derived attributes. So in general, we store our attributes, save it in database. So therefore, more than 99% of the time, those are stored attributes, the normal elliptic shape. But sometimes we can derive a particular attribute from another one or more stored attributes. So then we mark it using dotted lines or dash line, dash elliptic shape to denote that it is a derived attribute. So basically age can be derived from date of birth and current date. So therefore, yes, we are interested in age, but we don't store age. So therefore, we can mark it as a derived attribute, dash elliptic shape. You don't need to say from which one you are deriving it, but just show that it's a derived attribute. So then we have composite attributes. composite attribute means you can break it into sub-attributes. Again, it depends. There are no hard and fast rules saying this is a composite, this is not a composite. So one particular person, it will be a composite. For another person, it may not be a composite. It depends on the way you look at it. But in general, we can identify some attributes are composite. For example, address. Maybe we can break it into number, street, and city. Some people even break name into first name, last name, and initial mid names. And for some others, they just consider name as a single normal attribute. So therefore, we can use our common sense to decide whether it's composite or not. But when you're doing real world software development, it depends on your policies and so on, requirements. Okay? So how do you represent composite attribute? You have your composite attribute, and then from there you show what are the sub-attributes. So advantage is if you break it into sub-attributes, later when you design your database, so especially search by street, search by number, search by city will be faster and convenient when you write your SQL queries and so on. Okay. Right. So next one is multi-valued attribute. Multi-valued attribute is again attribute, but there's a possibility of multiple values for that. For example, salary is not a multi-valued attribute. Okay. Your name is not multi-valued. Name can be composite, but not multi-valued. Person can't have two names. Your name can have different parts. So that is called composite attribute. Multi-valued attribute means there's a possibility of multiple values for that attribute. So we denote it by double elliptic shape, like skills, contact number. Maybe you have 2 or 3 contact numbers. And usually, attributes, usually it's singular nouns, but if it is a multi-valued attribute, you can use a plural noun, like skills, contact numbers, and so on. Okay. Right. So any questions about entities? We are done with entities and attributes. Right. So next,
how do we use common sense to describe entities?
what do you mean by describe? You mean model or what is it?
Give some explanation.
So you don't need to give explanations, right? You just need to model it using rectangular shape. Right? You just model it using rectangular shape and model the attributes. That's it. And identify whether it's a identifier, multi-valued, derived, and so on. Okay, you don't need to explain it in ER modeling. Okay. Right. So the next thing is relationships. Because ER means entity relationships. So what is a relationship? So relationship in ER modeling is, so basically relationship is between entities, a logical association or logical connection between entities, 2 or more entities. Or sometimes the relationship can be between the instances of the same entity also. Okay. So how do you get it? Because in business domain, there's such relationship. Like student is following a course. So then there's a relationship between student and course. And employee is working for a department. So then there's a relationship between employee and department. Customer make an order. So that means there's a relationship between customer and order entity. So there's a payment done for a particular order. So that means there's a relationship between payment and order. Maybe payment is done by a particular customer. That means there's a relationship between payment and customer. So how do you find there's a relationship? Because there's such a relationship or association in real world. Okay. Right. So when it comes to relationships, of course, we want to give your relationship a name. And also we are interested in cardinality and degree of the relationship. Another aspect is role names. Those are optional things. Right. So this is how you model relationship. So these are the two entities. These are relationship between two entities. So binary relationship. And you draw this line and diamond shape and give relationship name. And this is your multiplicity. This is a one-to-many relationship. And optionally, you can give role names. Very rarely we do, but if it add values, you can give role names. Okay. So typically, either you give relationship name or role name, not both. But in rare situations, you can give both as well. So usually for relationship, we use a verb or something related to that. Whereas entities and attributes, we use nouns. Role name is also a noun if you go for role name. Okay. So these are some examples. You can see the relationship has a name, multiplicity is there. In the last example, we have used a role name also, which is optional. Right, employee works for department. You can see verb is there. And one employee can work for one department at a time. One department can have many employees. So customer make order. One customer can make many orders. One order is from one customer. Lecturer supervises a student, like project. Maybe one lecturer can supervise many students. One student must be supervised by one lecturer. And when the lecturer supervise students, the lecturer play the role of supervisor. This is a role name, which is optional, but sometimes it can be useful. Okay. So if you have any questions, you need to ask because I speed up now. Right. What are the possible multiplicities or cardinal?
Is the
Yes.
supervisor part of the process?
Not process. Supervisor is a role played by the lecturer. When he supervises a student, we can say lecturer is playing the role of supervisor because lecturer's main role is lecturer, lecturing. But this is additional role. So when you play additional role only, we go for that. So therefore, very rarely we use role names. But if the entity, its main, if this is not your main role, you can give the role name. If it is your main role, usually you don't need because then it's additional. Unnecessarily you are explaining it twice. For example, when customer make an order, customer's role is customer. Therefore, you don't need to write it because it doesn't add value. But lecturer's main role is lecturing. But this is additional thing because lecturers work act like supervisors for the project. So that is why we have shown it. So likewise, we don't just model something for the sake of modeling. We model something if it is important, if it adds values. Okay. If it makes sense. Is that relationship of entities determined by attribute that share? Your question is not clear. Maybe your question is incomplete. Okay. Right. So what are the three possible multiplicity values? So cardinality values, one to one, one to many, and many to many. So one to one means, so again, you must be very precise in your definitions. So we say that A and B has one-to-one relationship if one instance of A is related with one instance of B and one instance of B is related with one instance of A. So then we say it's one-to-one. Okay. Or you can say one instance of A is related with one instance of B and vice versa. අනිත් පැත්තට එහෙම. So these are some examples. Okay. Husband married to a wife. One husband, one wife. One wife, one husband. One-to-one. Maybe one country represented by one national flag. For one country, one flag. For one flag, one country. So it's denoted by having both sides one. Usually one to many, you very rarely denote. But usually you denote one to one and many to many. But sometimes we denote one to many also. It depends on your preference. Right, so then one to many, one instance of A is related with many instances of B, and one instance of B is related with one instance of A. So then only we say it's one to many. Give your full definition, precise definition, the best definition. So it can be either one to many or many to one. So you don't call it many to one because when you look at it from other side, it's again become one to many. So therefore we just say we have one to many and many to many. But when we say one to many, it can be many to one if you look at it from other side. Right. So these are some examples of one to many relationships and how it is modeled in business ER. Mother has many children. One mother can have many children, and one child belong to one mother. So therefore here one. One department can have many employees, but for one employee, we have only one department. Both are one to many relationships. Finally, you can have many to many relationships. So many-to-many relationship means one instance of A is related with many instances of B, and one instance of B is related with many instances of A. So then it is many-to-many. So there are practicals in our many-to-many relationships. Like employee and project, student and course. Okay. Right, so next concept is degree of a relationship. Degree of a relationship. So degree of a relationship specifies how many entities are involved for a particular relationship. So mostly your relationships are binary. So far, all the examples are binary relationships. But it is not necessary. There can be relationship with its own entity, unary. Of course, binary between two entities, most popular. Then ternary between three entities, or even n-ary, 4, 5, 6 entities related together. Right. So we'll take a small break and then continue with ER modeling. Okay. So today we'll spend more time on database. Okay. Right. So now it's 10:50. We'll take a small break, 10 minutes. We will start at 11 and try to finish ER modeling. Okay. Because this is a very simple topic. Right, so let's move on to binary relationships. Right, so remember your multiplicity can be one-to-one, one-to-many, or many-to-many. Okay, one-to-one, one-to-many, or many-to-many. One-to-one like mother and child. Sorry, one-to-one like husband and wife. One-to-many like mother and child. The mother can have many children, child have only one mother. And also it can be many-to-many. Okay, many-to-many. That is something like employee can work for many projects, and one project can have many employees. Student can register for many courses. One course can have many students. So that is multiplicity. So the next concept is degree of a relationship. So the degree of a relationship can be binary, unary, ternary, or n-ary. So most of the time what we see is binary relationships. That is, relationship is between two different entities, like employee and department, student and course, right? So those are binary relationships. The relationship is between two different entities. But there's a possibility that you can have, so these are all binary relationships. Okay. So binary relationship can be one-to-one, one-to-many, many-to-many. Those are independent concepts. Patient and doctor, order and payment, cause and subject. Okay. So then you can have unary relationships. What is context of these relationships? So the context is business. For example, you can think that patient is coming to see a doctor. Doctor is treating a patient. So that is the context. Context is your business domain. So when you go to business organizations, you should see that there are orders and there are payment for those orders. So once the payment is done for the order, maybe the goods are released. Okay. So the simple answer is common sense. See the world, how things happens in business organizations, education institute, hospital. So that is your context. Okay. Or we call it domain, or bank, or factory. Right. So what is mean by unary relationship? So unary relationship is a relationship between entity instances of same type. So far, different entity types, right? An employee work for a department, employee and department. But this is relationship between instances of the same entity. So that is possible. That is possible. So then we say there's a relationship which is unary relationship. And again, that unary relationship can be one-to-one, one-to-many, or many-to-many. Okay. So these are some examples, typical examples. Okay. Say employee can be supervised by another employee. So supervisor is also an employee. So maybe one supervisor can supervise many employees. So then we say you play the role of supervisor. And if you are a non-supervisor, you are supervised by one supervisor employee. Right? That is, you are not a supervisor. But if you are a supervisor, you supervise many employees. So it's the relationship is between two employees, which is one-to-many. And therefore, it's a unary relationship. If you take something like Facebook, social media like Facebook, a particular member can have friendship with another member. So you are a Facebook user, I am a Facebook user. Maybe I am a friend of you. But it's that relationship is between instances of the same type, users. And this can be many to many. Right? A particular member can have many friends. And if you take another member, so that member also can have many friends. So I have many friends and my friends also have many friends. So friendship is between two members. So therefore, it's a unary many-to-many relationship. So it can be unary one-to-one, unary many-to-many, unary one-to-many. So the third category is ternary relationship. So this is the hardest to understand. You need to be a little bit more serious. So this is a relationship between three entities. Three entities. So this is not two binary relationships. Sometimes you feel like, okay, maybe it is something like this. No, this is two binary relationships. And this is one ternary relationship. One ternary relationship. So therefore, this relationship is between three instances of different entities or same entity. It depends on whether again unary, sorry, not two instances. It's definitely between three entities. Three different entities. So entity means different role or different type of major concept. So ternary relationships are a little bit rare, but if there are such situations, you have no other option but to consider it as a ternary relationship as well. Okay. Right. How can we get a ternary relationship? Can you think of practically? Now I have explained you some practical binary relationships, student and course, employee and department, order and payment. Then some unary relationships. The supervisor relationship is between two employees. Friendship is between two members. So can you think of a ternary relationship? So that means in order to explain the relationship, you need to use all three together. Can you give me example? Right, I have given you one example here, within two examples. That is,
The many-to-many relationship එකක් පිටින් table එකකට කැදුවම එන relationship එක තියෙනවා.
can you explain it slowly? Because I can't get it.
Many-to-many relationship එකක්
Or
කඩලා bridging table එක connect කරාම ඒ එන relationship
nah,
many-to-many
ඒක වෙන කතාවක්. So that is many-to-many relationship එක එතකොට තාම ඒක binary. So that is still binary. So this is different. This is ternary relationship. Ternary relationship. So this is a relationship between three things. Okay, three entities. So this is a different story. Okay. This is a completely different story than binary many-to-many relationship. So here you need all three together to understand that relationship. You can't explain that relationship by taking only two of those. So then only it's a ternary relationship. Okay. For example, say you are selling something like your land. So then there's a transaction, right? There's a transaction. So one entity is buyer. Other entity is seller. Can you think of the third entity? During when we do this transaction. Anyone? Anyone? Maybe a lawyer or something? Because when you prepare the deeds, it's now you know that three parties signed, right? Buyer, seller, and the lawyer, or the whatever the relevant official. So this transaction is Yes, it's between buyer and seller, but there's a third party also approving it, witnessing it. So then it's sort of a ternary relationship. Right? It's a ternary relationship. You can't break it into two or three binary relationships because it's between X and Y, approved by, witnessed by Z. So that is the transaction. Okay. Maybe you are selling some product, say using Daras or something, and also you use some other platforms. So then buyer, seller, the agent. Through this agent, this transaction happen. Buyer, seller, agent. So likewise, there are situations, relationships are actually ternary. Ternary. Okay. So this is another example. Product, brand, and store. So assume there are different brands like LG, okay, Samsung, and so on. So Cecil. So then there are products, say TV, washing machine, okay, fan, and so on. Let's forget about the subcategories like different type of fans and so on. Let's say just one type fan. Assume we have stores. We have store in Colombo. Say we import these items and maybe we redistribute them. We have a store in Jaffna. We have store in maybe Candy. Now, if you want, you can model it as two binary relationships. That is, product is related with brand, right? And maybe brand is related with store and product is related with store. But that doesn't make much sense. Ideally, it should be a ternary relationship. Especially if you want to keep track. For example, how many Samsung TV available in Colombo branch, Colombo store. So if you have such kind of a requirement, so you need to model it as ternary relationship. Ternary relationship. So the product details here, product ID, product name, and so on. Brand details here, store details here. And if you want how many Cecil fans available in Jaffna, say 12. So that details, if you want to keep track, you must model it as ternary and that attribute will actually go there. Number of items. So at the beginning, it will be a little bit confusing. Actually, what happens is you will find that maybe you will try to model it use in different way and try to develop also, implement, design. And every time you try to design it and develop it, you will find that there are issues. It doesn't work, it doesn't work, it doesn't work. But ultimately, you will find that if you model it as ternary relationship and then proceed with your design, now you can keep track of these number of items. How many Cecil fans are in Jaffna? How many LG washing machines are in Colombo? So you can answer that question if you model it as a ternary relationship. Otherwise, you will not be able to track it. So likewise, it's a practical scenario. Due to practical problems, we model it as ternary relationship. Modeling it as two binary relationship doesn't work. Actually, it doesn't solve our problem. So that is why you need a bit of experience. Doing these exercises, practically start designing, analyzing and designing databases, systems, and so on. So this is a practical subject.
The one question.
Yes.
මේක complexity දැන් entities තුනක් තියෙන නිසා complexity එකක් තියෙනවා. එතකොට හැම විටම many to many ද එන්නේ එකිනෙක අතර.
බොහෝ විට මෙනුට මෙනි තමයි ඔක එන්නේ. ඒ තියෙන කතන්දරෙත් එක්ක නේද? So one product you can have many brands, right? So one product can be in many stores and so on. Okay, so most of the time it will be many to many. Usually,
ඒකට අපිට මේක සිම්ප්ලිෆයි කරන්න ඕනද one to many විදියට?
huh?
මේක සිම්ප්ලිෆයි කරන්න ඕනද one to many විදියට?
නෑ. ඒක ඩිසයින් කරද්දී අපි දැන් කතා කරනවා. ඒක one to many විදියට simplify කරන්න මේ විදියටම අපිට ඩිසයින් එක ඉස්සරහට ගෙනියන්න පුළුවන්. Right? We don't need to do that. So that means in a way yes, but we need to introduce another table here. So same solution as many to many binary. In many to many binary also we introduce a table, intermediary table. Here also we introduce intermediary table, but that is not we are breaking it sort of a one to many. It's basically we are having an intermediary or connecting table. Okay, connecting table. So in a way we are breaking it to one to many also. So this is then it will become this is one to many, this is one to many, this is one to many. Yeah, I think ultimately your question for your answer is when you go to designing, still we are not discussing about designing. The solution is we break it into 4 tables where you have 3 one-to-many relationships. 3 one-to-many relationships. Okay, I think yeah, ultimately the answer is yes. Basically, yes, we break it into 3 one-to-many relationships. Right? But let's not worry too much about designing right now because still we are in the analysis side. So designing will take separately in our next topic. Okay? But anyway, you can think of the designing right now. Of course, no one can restrict. Right? Or මේ වෙලාවේ design ගැන හිතන්න 100ක් අවස්ථාවක් තියෙනවා. And that is good actually, right? You come up with possible solution, right? But we will separately look at the designing later. Okay. So meanwhile, yes, you can think of possible how to design it. Okay. Right. So that is called ternary relationship. Right? Ternary relationship. It's a relationship between 3 entities. 3 entities. Okay. Right. So now we have covered, of course, if it is more than 3, we call it n-ary, which is very rare, like relationship between 4 entities, 5 entities can be there, but very rarely we encounter that kind of relationships. And again, the solution is pretty much the same. Okay. But ternary relationship, time to time, you will see. In your exam papers, you will see even A-level ICT papers, they have given ternary relations situations. And when you're developing software, for example, when final year students develop their software, sometimes they encounter ternary relationships. So then they need to handle it. They need to handle it. Because you can't run away from ternary relationships. If reality demand ternary relationship, you must accept it and tackle it. Okay. Right. So now we'll look at another aspect. So there can be, remember there's a possibility of strong entities and weak entities. Right. So every time there's a weak entity, there's a relationship with that to a strong entity. So that relationship also, remember the weak entities are modeled using double rectangular shape. So that relationship with the relevant strong entity is also represented as a double diamond. Right? So therefore, not only your weak entity is double rectangular shape, the relationship itself is also double diamond, double line diamond. And connecting the relationship and the weak entity is also represented by double line, but not this side. This is a strong entity. Okay, so therefore, this is your weak entity, and this is your weak relationship, or the weak side of the relationship. So this is the dependent one. This is your major one, major concept. Okay. Right. So the next concept is associative entity. So there's a possibility of associative entity. Associative entity means it's associate. Association is another name for relationship. Associate කියනවා කියන්නේ සංගමයක්, ආශ්‍රයක්. ඒ කියන්නේ සම්බන්ධයක්. So there are some associations or relationships which leads to an entity. Usually association is not entity. Association is an association, or relationship is a relationship. But some relationships result in an entity. So then we call those relationships or associations as associative entities. Okay. So there are two major places you can identify associative entities. That is, if it is a many-to-many relationship, definitely you can identify associative entity. That relationship itself is an entity. So second place is when you have ternary or higher, that also results in associative entity. And later on when we design, those associative entities will become independent tables. Just like your entities become tables, your associative entities also, they are going to become new tables. So not every association is associative entity. But if it is a many-to-many association or ternary association, it's going to be associative entity. And in the future, it's going to be a connecting table. Okay. And so this is an example. An employee can work for many projects. That means at a time, employee can be assigned to many projects. And at a time, one project can have many employees. So therefore, this is obviously many-to-many. This is many-to-many relationship. So when we have many-to-many relationship, we can consider this as an associative entity. Okay. It's not a must, but sometimes you consider it as associative entity. And some books we mark it also like this. It's both association or relationship and entity, because entity is this. But in your BIT papers, usually the examiner doesn't mark associative entities like this. So your examiner just mark it as a normal entity, a normal relationship. But if you see attributes there, definitely examiner has identified it as associative entity. If you see at least a single attribute for a relationship, that means it's associative entity. But some people, they just mark it like entity also. Okay. Right. So then you must think, why do you need to mark attributes in the association? Can't we mark it here or there? The simple answer is no, you cannot. It doesn't make sense. It makes sense only when you mark it here. There are some attributes, it makes sense only if you mark it here. For example, if you take employee's name, naturally fit into employee, employee ID, employee salary, right? Project ID, project name, project budget. Yes, it fit into this. But what about number of hours a particular employee has worked for a particular project? Because employee can work for many projects. Project can have many employees. Animal has worked 10 hours for project 1 and 12 hours for project 2. Kamal has worked 20 hours for project 1 and 5 hours for project 3. Now, where do you keep these 12 hours, 5 hours, and so on? It doesn't fit in here, because for different project, that employee can work for many hours, different hours. It cannot keep here, because then it isn't only related to project. So if you are referring to, say, Nimal for project 1, Kamal for project 2, or Kamal for project 3, you can say I am referring to both. That kind of attributes you need to put it there. That kind of attributes you need to, but these are only for Nimal. These are only for project 1, but this is Nimal has worked 10 hours for project 5. That kind of attributes which refer to both must be marked in your associative entity, because anyway later we are going to make it a table, and those attributes will be part of that table, connecting table later on. Okay. Right. So that is one possibility of associative entity when we have many-to-many relationships. And the other possibility is when you have ternary relationships. Okay. So this is another one. Student can follow many courses. Course can have many students. So this is the date of registration. That is, Nimal has registered for FIT in this particular date. Nimal has registered for BIT in that particular day. Nimal has paid, say, 20,000 for FIT so far. Nimal has paid 15,000 for, say, some other diploma. So this fee is this student for this course. And this date of registration is this student for this course, because for different courses, he may have registered in different days. So many to many, there's a possibility of your relationship is an associative entity, and it can have its own attributes. And as I told you, the second possibility is when you have ternary relationships, so ternary or higher, then there's a possibility of having attributes in which cannot fit into product or brand or store in this case. That is something like how many Singer washing machine in candy store. Singer washing machine in candy store. So I'm referring to all three. So that amount you can keep it here. That amount you can keep it here. Not here, here or there. Okay. So that this is another possibility of a associative entity. Right. Any questions? Any questions? Right. So we'll stop at this point for the database, because extended ER modeling we want to take separately because it's related to object oriented. Remember, we have done object oriented in semester 1 programming. So refresh those things before the next class so that we can discuss those things and finish it. And then we'll do some past paper questions as well. Okay. Right. So we have not finished ER modeling. Okay. We are now more than halfway. We are more than halfway. Right. So we'll take small break and then we'll move on to communication skills, because we want to start communication skills also today. Okay. We'll take only 5 minutes break. 11:37. Okay, let's start 11:45. And it will be communication skills. I unofficially did a small session on, few sessions on communication skills in semester 1, but we are not going to, we predominantly discuss English grammar. We are not going to do the same thing. We are just going to do the your syllabus now. Okay, right. 11:45. This will be a small session, right? About half an hour session. Okay, so let's continue. Now we move on to the communication skills, right? So remember, communication skills is a EN subject. EN subject means you don't get ABC for this subject, but if you fail EN subject, automatically you are disqualified to go for the level 2 until you next time do that and pass it. Okay. So therefore, you must be serious about EN subjects as well. Right. So again, our notes are there and also UCSC notes are there. Mostly we will be using the UCSC notes for this subject, communication skills. So this is syllabus. These are the VLE notes until you get the university VLE access. Okay. So then the notes are there. And I have uploaded, these are supplementary for communication skills. And for most of the semester 1 batches, I went through these in semester 1, grammar. But we are not going to do it again. But as a supplementary, I have given you some recordings from some other classes. But that is optional. Those are optional. Recordings on English grammar. Okay, English grammar. I think about 4 recordings are there that cover these notes. So most of these notes. Okay, but we will not be doing that. That is, if you are interested, right, you can go through the notes and also go through the recordings. We will be concentrating on your syllabus. Okay, because we have covered these things in semester 1 as additional thing. Right. So the other thing is, so related to this, because this communication skills subject continues in semester 3 also. Right. Semester 3 also you have communication skills 2. Again, enhancement subject. And especially those who are new to our classes, make sure you go through these 2 topics as well. Right. Effective studying note and successful career and life note. Because though we call it communication skills, especially the semester 3 communication skill is all about your professional skills. So how to become a good IT professional. Okay, so the big picture is professional skills. But in semester 2, we will cover most is communication skills, and semester 3 will cover additional things like leadership, teamwork, and other aspects. Okay, right. So therefore, again, I repeat, make sure you go through these, especially the successful career and life, because it covers a lot of aspects, not for your exams, but for your career itself. Okay? And effective studying is how to study with less effort and get good results. Okay, the art of studying, science of studying. Right. Right. So let's move on to our topic. Right. But I'll give you overview. Then I'll get into your notes. Okay. Right. So when it comes to your professional life, professional career, if you take your life, right? So you are a human being. You are a human being. So you can identify different aspects of your life, right? How do you categorize your aspects of life? Anyone? මට මෙහෙම ජීවිතයක් තියෙනවා මෙහෙම ජීවිතයක් තියෙනවා මෙහෙම ජීවිතයක් තියෙනවා මගේ මේ ජීවිතය සාර්ථක කරගන්න ඕන මගේ මේ ජීවිතය සාර්ථක කරගන්න ඕන කියලා. How do you subdivide? Anyone? මේකට හරියට මේකයි උත්තරේ කියලා ගන්න. ඔයා කොහොමද ඔයාගේ ජීවිතය බෙදාගෙන තියෙන්නේ? එහෙන් බෙදාගෙන නැද්ද? So I need answers. How do you look at your life as an adult? So තාම එහෙම බෙදාගන්න තරම් ලොකු ජීවිතයක් නැද්ද දන්නේ නැහැ. තාම දෙමව්පියන්ගෙන් කාලා බීලා
Professional life,
yes, professional
What is-
life is one. What else?
social life,
Yeah, maybe social life. Then what is the other one? That is your own private life. ඔයාට ඔයාගේම කියලා ජීවිතයකුත් තියෙනවා නේද? Private life. So that is neither professional life or social life. ඔයාට හිතෙච්ච දෙයක් හදාගෙන කනවා, ඔයා හිතෙච්ච තැනකට යනවා. ඒක social උත් නෙමෙයි professional උත් නෙමෙයි. හරි? ඔයා කැමති දේවල් කරනවා. ෆිල්ම් එකක් බලන්න යනවා. So that is your private life. So as a human, right, at the end, you must be happy about all three. Happy about all three. So you must feel like I have my own good personal life. Let's say personal. I have a good social life. I have a good professional life. Okay. So not everyone is lucky to have all three good lives. Right? Sometimes your professional life is good, but your personal life is not that good. Sometimes your personal life is good. Sometimes you don't have any professional life at all. Okay? Sometimes not very good social life. Right? So we are more interested in your professional life. Right? Professional life. So when it comes to your profession, right, to have a successful profession, because one affects the other. If you have terrible professional life, it affects your personal life and your social life. And vice versa. When you have terrible personal life, it affects your professional life. ගෙදර ප්‍රශ්න නම් හරියට උතර කොහොමද life එකේ profession එක කරගෙන යනවා. So therefore these are interrelated. Right. So when it comes to your profession, it depends on few aspects, so success or failure. So can someone tell me which aspects determine the success or failure of your professional life? Forget about the personal, influence අයින් කරොත් එහෙම. Anyone? To have a good professional life, successful profession, what are the things you need? Anyone? මේක දන්නේ නැත්නම් successful professional life එක හදාගන්න බැරි වෙනවා.
Have a good career.
Yes, my question is how to have a good career. What are the preconditions? What are the prerequisites? What are the things that you need to have in order to have a successful professional life? For example, Muttaya Muliridharan had a successful professional life as a cricketer. So likewise, there are successful doctors, engineers.
Education.
Okay. So I'll take it as knowledge. Okay, knowledge. Because education, the result is knowledge. Right. What else? Skills and competencies. What else? So unless you have skills and competencies, no one will care about you. No one will care about. What else? Right. Ethics. Okay. Otherwise, ඔගොල්ලෝ හිරේවි ළඟට යන්න දෙන්න. හිරේවි නේ. පගාව අරගෙන ජරාව කාලා උසාවි ගන්න යනවා. නැත්නම් සමාජයෙන් අපවාදයෙන් ලක් වෙනවා මු හොරා ජඩේක් කියලා. ethical නැහැ. හොරකමින් ජීවත් වෙන එකෙක් කියලා. තමන්ගේම සර්ද සාක්ෂියකෙක් කියනවා ජරාවෙන් තමයි මම ජීවත් වෙන්නේ හොරා කාලා මොන ජීවිතයක්ද මම ජීවත් වෙන්නේ කියලා. And what else? Knowledge, skills, competencies, ethics, and of course your attitude. Actually, number one is attitude. Right? Number one is attitude, like your driving seat. Right? Attitude will drive either this way or that way or the other way. So then your skills and competencies. Actually, no one cares about your knowledge anymore. Right? No one cares about your knowledge. But if you can convert your knowledge into skills and competencies, yes, everyone cares about your skills and competencies. That is very important. So knowledge itself has no value. unless you are going for exam. විභාගයට යනකොට විතරයි knowledge එක ඕනේ. එතනින් එහාට ඔයාගේ knowledge එක වැඩක් නැහැ. But knowledge is important to build the skills. So the knowledge that you don't use for building skills and competencies is a waste of your time. Okay, it's a waste of your time. But everyone is looking for your skills. Can you build a website? Can you develop a software? Can you manage our information system? And of course, everyone is interested whether you are an ethical person, professional person. Okay, right. So anyway, the ethics part is covered as a separate subject in your final year, professional practice. But here we are interested in skills and competencies. So these skills and competencies we can subdivide into some categories. What are those categories? How can you subdivide skills and competencies of professional? What are the type of skills that you need? Types of skills for a successful career.
Communication skills.
Yes, communication skills come under which category? How do you call that big category?
Language.
No. So we categorize them as technical skills, soft skills. Okay. Technical skills and soft skills. So your technical skills, that is why you have the subject programming, database. Now, database is the technical skill, right? Networking, web development. So those are technical skills for a IT professional. If you are a doctor, what are the technical skills? So, what ECG how to read ECG, how to do a small surgery, how to treat a wound, right? How to read a scanning report. So that is technical skills. Technical skills here, technical for accountant, what are the technical skills? How to interpret a profit and loss, ratio analysis. Okay. So those are technical skills. So business person, how to come up with a business proposal. So those are technical skills. So every professional must have the relevant technical skills. Then you need to have soft skills. So the soft skills include conceptual skills like problem solving, analytics, logical thinking, critical thinking. So those are conceptual skills. Those are the soft skills. So then you have other soft skills, which includes communication skills, leadership, teamwork, right? So those are other soft skills. So this subject is concerning about these soft skills, not the conceptual soft skills. Your semester 2 communication skills subject is mainly looking at the communication skills. But semester 3 communication skills, communication skills it must be soft skills. Syllabus leadership skills, team skills, and other soft skills. Okay. So why? Because just because you are having technical skills doesn't make you a good professional. Just because you are really good at your programming databases, it doesn't mean that you can be a good IT professional. So you need soft skills, including these conceptual skills. Because otherwise you can't go for an interview and get the job. You can't, otherwise you will not be able to work as a team, as a good team member, take leadership, work with your customers, work with your team members. So that is why these soft skills are super important. So you can't forget about soft skills. Right? Some people, so they don't have soft skills. So they are even afraid of going for interview. What is the point? Then how can you start your career? Career එක පටන් ගන්නවත් බෑනේ එතකොට. ගෙදරට ඉන්න වෙන්නේ. සමාජයට බහින්න බෑ. ආයතනයකට යන්න බෑ. Soft skills නැහැ. Communication skills නැහැ. කතා කරන්න කට ඇරෙන්නේ නැහැ. So that means they have forgotten about these things. They have just concentrating on their, maybe they have not even concentrated on their technical skills. They have only concentrated on their knowledge. Knowledge අරගෙන පාඩම් කර කර ඉවරයි. ඊට පස්සේ රැකියාවේ විදිහට උපාධාරීන් කියලා නේද? එකම උටපටයක්. So therefore don't take this lightly. Build your technical skills. දැන් සමහරුන්ට බෑ ෆයිනල් ඉයර් ගියාට පස්සේ වෙබ් පේජ් එකක් ඩෙවලොප් කරගන්න බෑ, software එකක් ඩෙවලොප් කරගන්න බෑ. බෑ ඇත්තටම මම දන්නේ මොන ජීවිතද කියලා. ෆයිනල් ඉයර් ඔය ස්ටුඩන්ට්ලා ඉන්නවා ෆයිනල් ඉයර් ප්‍රොජෙක්ට් එක අල්ලන්නවත් බෑ ඒගොල්ලෝ. බොරු කර කර ඉන්නවා. ඊට පස්සේ කෝස් එකක් අරලා දාලා යනවා. ඔයගොල්ලෝ හිතනද ඔය හැමෝම ඩිග්‍රී ගන්නවා කියලා ෆයිනල් ඉයර් පිස්සුද? 150ක් විතර ප්‍රොජෙක්ට් එක කරන්නේ නැහැ. අය ඩිප්ලෝමා කරන් නවතිනවා. So that means they have never ever thought about skills, not even technical skills. Because at the end of your level 2, you must feel like now I can build a software. If not, you haven't done your job, right? Your studies properly. You have just concentrated on memorizing this and that rather than developing the skills. Skills, that's something you need to develop. Right? You need to develop by doing things in a practical manner. Right. So then you can't forget about the soft skills. You can't forget about the soft skills as well. Okay. Right. So what are the soft skills? Leadership skills, communication skills, teamwork. Those are the three major soft skills. Three major soft skills. Okay. Right. So out of those, in this semester, we will be more concentrating on communication skills. Okay? Communication skills. Right. So let's open your first topic. I'll first show you the syllabus. So we will not take much time for this subject. This is something you need to study. That is why it's a EN subject anyway. Right. So these are the subtopics: writing and typing, mechanics of writing, writing for a purpose, listening for a purpose, small talk and general communication skills, presentation and public speaking, reading for a purpose, summarizing and paraphrasing. If you have come to the BIT through FIT, actually you have done these things in your FIT itself. Because in FIT, these things are covered, but not in a very serious manner. But here we will be more serious about those. Okay. So basically, these are different aspects of communication. And again, so today I'm just going to give you overview only because these things we can do sometimes 3 topics in single day. Okay. 3 topics in a single day. And within 4 or 5 days, we can finish it. So my task is give you the overview, the big picture, right? So don't take this only for exam. So this is more than for exams, okay? For your career, your life. Right. So when it comes to communication, again, there are different type of communications, right? Communication means what? By the way, what is mean by communication? Anyone? If someone asks what is communication, what is your answer?
Exchanging,
Yes.
exchanging information on two parties.
Yes, it's exchange of information, right? Exchange of information is called communication. It can be between human to human, human to computer, right? Computer to computer, right? So that is networking. So that is why sometimes we say IT or ICT, information and communication technology. So computer to computer. So here we are interested in human to human communication. So that is exchange your ideas, right? Information, or you want to explore things, and so on. So when we say human communication, so there are different aspects of human communication. Can you categorize the different aspects of communication? Because you must know what kind of communication you are doing and do it in the proper way. Do it in the proper way. Can you categorize those? I want answers from you guys. ඔයා කොහොමද ඔයාගේ communication classify කරන්නේ? මම මේ වගේ communication කරනවා, මේ වගේ communication කරනවා, මේ වගේ communication කරනවා කියලා. Anyone? මේවා අනිවාර්යයෙන් ඔයගොල්ලෝ උත්තර දෙන්න ඕන දේවල්. Right. Verbal writing is a different classification. Yes, that is also classification, but that is not what I am expecting. Depending on the context, you can classify that I'm now doing this kind of a communication, this kind of a communication. So why don't you talk? Communication skills, communication subject එක කතා කරන්න පොඩ්ඩක්. එතකොට න්යාගේ confidence build වෙන්නේ. ලැජ්ජද?
So formal, informal.
Yes, one is yes, formal and informal, right? So informal communication, I will put it as sort of a casual communication, right? So that is basically informal. Where do we do informal communication? Can you give me example? Some examples of
Between friends.
Yeah, you talk with having some chat with your friends, family members, right? Maybe your neighbors. It's very much an informal communication, especially with friends and family members. Or casual communication, right? So then we have the formal communication. So formal communication, we can subdivide it into two. One is called business communication. Like how you communicate with your customer, right? Or you communicate with a business organization, you go to the bank or some other place. It's a business communication. Especially how do you communicate with your customers, clients? Okay. So the second formal communication is academic communication. Academic. You prepare a report, thesis, even writing an answer, assignment. Right? So that is academic communication. That is also formal. You must do it in a form. Not much of a difference, but slight differences are there, at least for the purpose. So what is the third category? So here you must be formal when you are communicating, right? But here don't be formal. If you are formal here, everyone will find that you are a strange person. Be sick here. At the same time, if you are too casual here, so it's not going to work. What is the third category? Anyone? Again, you do communication. So that is literature. Literature. So you write a poem, short story, maybe you want to write a song. එතෙන්දි වෙනස් නේද? ඔය හැසිරෙන විදිය. ඔයා business letter එකක් ලියන විදියට සින්දුවක් ලියනවාද කවියක් ලියනවාද? So that is a different story. So your mindset is different. Your selection of words are different. Okay. So literature, formal communication, which can be business or academic, and your informal or casual communication. So you need to adjust. Yes, it is the same, similar words, same grammar, but you need to adjust. Right? But in this subject, we are more interested in formal communication. That is business or academic communication. Okay, business or academic communication. Right. So when it comes to formal communication, that is business or academic communication, what are the good features of a good formal communication? Now you need to talk. So if you do your communication like this, we can say you are doing a good job. Because the purpose is either business or academic. Not a chit chat. or make fun of it or give you a aesthetic feelings. No, business or academic. Which kind of a which attributes make your formal communication good communication? So don't worry, your answer can be correct, maybe somewhat correct, maybe wrong. That is fine. But have your confidence because you can't say, I don't know what are those features. එහෙම කියන්න බෑනේ ඉස්කෝලේ ගියේ. සිංහල කොච්චර ඉගෙන ගත්තද පීරියඩ් අවුරු මේ සිංහල ඉංග්‍රීසි. Right. Communicate on point. That means make sure you only communicate relevant things. වල්පල් කියන්න බෑ මෙතන. ඔය එක්සෑම් එකේ ආන්සර් එකක් ලියද්දි වල්පල් ලියන්නේ නැහැ. Business communication නම්. සමහරව මේක දන්නේ නැහැ. Some people they are not aware of these things. දැන් සමහරව අපිට කෝල් කරනවා. අපිට කෝල් කරන්නේ යාළුවෙක් කවුරු හරි නෙවෙයි නම් කෝස් එකක් ගැන හරි ක්ලාස් එකක් ගැන හරි යන්නේ. ඊට පස්සේ වල්පල් කියනවා. සමහරව කියන මම මේ අහවල් අමාත්‍යාංශයෙන් කෝල් කරන්නේ. මම බලන්නේ ඔව් මේ අහවල් අමාත්‍යාංශයෙන් කොහොමද උටපටයක්වත් වෙලාද කියලා. ඒක අපිට අදාළ නැහැ. අමාත්‍යාංශයෙන් කෝල් කරත් අහවල් පන්සලෙන් කෝල් කරත් මම බලන පන්සලෙන් කෝල් කරනකොට මම කො දානවත් බාර දීලාද කියලා අපිට. That is not relevant to us. So if you're interested in our deep courses, so yes, let's straight into our discussion. So make it relevant. So when you write an answer, when you write an assignment, when you communicate, so UCSC එකට call කරොත් මොකක් හරි ප්‍රශ්නයක්. ඔයා කියනවා මම මේ තනමල් වලින් call කරන්නේ. එහෙම අදාළ නැහැ. මම මේ BIT student කෙනෙක්. මෙන්න මේ ප්‍රශ්නය වල මම මෙන්න මේ registration එකේ මෙන්න මේ ප්‍රශ්න තියෙනවා. That's it. Right? Make it relevant. Yes, what else? Right, accurate or precise. හරියටම කියනවා මොකද්ද ඔයාලට තියෙන ප්‍රශ්නය? මොකද්ද මෙතන කතා කරන්න ඕන? Precise. Yes, make it simple. තුන් තේරෙදි තෝර ඉන්න බෑ මිනිස්සුන්ට. Make it simple, straight, precise, relevant. What else? තව එකක් අපිට වැදගත් එකක් ආවේ නේද? Relevant, simple, precise, so accurate. හරි දේ කතා කරන්න බොරු කියන්නේ බා. Simple. තව ඉතා වැදගත් දෙයක් තියෙනවා තාම ආවේ. Short. Or we call it concise. කෙටියෙන් කියනවා. සරලව කියනවා. අදාළ දේ කියනවා. Accurately කියනවා. So that is what we are expected when you are doing business communication, when we do academic communication. For example, when you go for an interview, it's a business communication. So when someone asks you a question, make sure you give one relevant answer, precise answer, simple answer, short answer. Short කියන්නේ හැම එකටම හුම් ගාලේ නේ නෙමෙයි. උත්තරේ තියෙනවා අනවශ්‍ය දේවල් තියෙනවා. අනවශ්‍ය දේවල් කියනකොටම ඉන්ටර්විව් එකෙන් කැපෙනවා. වටේ යනකොට දන්නවා මුට මෙලෝ කොන්ෆිඩන්ස් එකක් නැහැ. මූ නිකන් මේ කාලේ කන්න හදනවා. කාලේ ගෙවන්න හදනවා. එයා ඉන්ටර්විව් එකේ හිටියා කියලා පෙන්නනවා. මොකද ඔයාට වැඩිය 10 ගුණයක් ඔළුව තියෙන මිනිස්සු තමයි ඉන්ටර්විව් කරන්න ඉන්නේ. හරි. ඒ මිනිස්සු හන්දන්න වඩා අමාරුයි. So when you are confident, you are up to the point. When you are not confident, you go here and there. So other person can sense it straight away. Right? It is not how many words we use for your answer matter. No. Have you answered the question? Point. Have you justified your point? That is what matters. Not how many words, how many sentences. So that's very, very important, right? Relevant, precise, simple, short. In some final year papers, so the examiner specifically say, explain this in 2 sentences. 1 sentences. කෙලින්ම කියනවා paper එකේ. එක වාක්‍යයකින් විස්තර කරන්න. මොකද නැත්නම් මේගොල්ලෝ බයිලා ලියන්න පටන් ගන්නවා. එතනින්ම එතකොට වාක්‍ය දෙකක් තුනක් දීවම ලකුණු නොදින්න පුළුවන්. මොකද මේ control කරගන්න ඕන. So don't think that the lengthier is the better. Okay. So maybe that is when you are doing this kind of thing, aesthetic things. නේද? මම දන්නේ මට ඉස්කෝලේ යන කාලේ තිබිච්ච පොදු ලොකුම ප්‍රශ්න තමයි රචනයක් ලියන්නේ කොහොම රචන ලියාගෙන යනවා. ටීචර් කියනවා අනේ තව පිටුවක් ලියන්න පිටු භාගයක් ලියන්න. මම දන්නේ මට නම් හිතා ගන්නවා ඉතින් මට කියන්න දෙන ඔච්චරයි ඒක. Because from my young age, my mindset is on science engineering. Right? Maybe my teacher is more into the arts. So one of the biggest issue in our language, when we teach some language, it's more towards aesthetic. ඒක තනි කරම කලාව පැත්තට බර කරලා දැන් ගන්න. නෑ කලාව පැත්තට බර කරලා language ගන්නන්න බෑ. communication ගන්නන්න බෑ. ඔක්කොම කව කරන්න. කෙටියෙන් සරලව ලියන විදිහට ගන්නන්න. So we are more interested in this. Okay? We are more interested in this. Right. So that is how you do professional communication. Okay. Relevant, precise, simple, short, or concise. Okay. So that is your communication. So remember, when it comes to communication, there are two aspects again. Verbal communication, non-verbal communication. I'm just giving you the big picture. So if you want to be a good communicator, yes, you must concern about your verbal communication. At the same time, you must care about your non-verbal communication. So verbal communication means how well you communicate using words. Words, grammar. Okay. The other thing is, if you want to be a good communicator, first of all, you must know your subject. Subject confidence. Otherwise, you can't be a good communicator, right? Subject එක නොදැන කතා කරන්න බෑනේ. එතකොට බයයි. Subject, and also if you feel like you have skills on that, competencies, that additional boost for you. So subject knowledge and skills. So that means your confidence on that side. Skills. But that itself is not enough. Then you need language skills. Language skills. So that means you must have sufficient number of words and you must be really comfortable with your grammar. So that is language aspects. So subject and domain aspects. Then interview එක කරනකොට subject එක දැනගන්න ඕන. ඔයාලට ඒක කියන්නේ skills තියෙනවා කියලා ඔයාලට හිතේ බයක් තියෙන්න ඕන. Then language. මට ඉංග්‍රීසි පුළුවන්, දෙමළ පුළුවන්, කතා කරන භාෂාව පුළුවන්, ලස්සනට හසුරවන්න. And the third aspect is the non-verbal aspects. It's partially conditioned by your personality as well. So what are the non-verbal aspects? Can someone tell me what are the non-verbal aspects of communication? මට කියන්න non-verbal aspects ටික. So verbal aspect is you use the correct proper words, proper grammar. You don't make too many grammar mistakes. Right? So non-verbal aspects. Right. One is body language. Body language. What else? I need at least 3. So attitude is, yes, attitude is also important, but attitude will reflect through these things. Attitude කියන එක වගේ ඇතුළේනේ තියෙන්නේ. ඒවා reflect වෙන විදිහ තමයි මම අහන්නේ. Body language is one. Okay, dress is, again, let's say it's part of your body language. What else? So body language, we can subdivide it into 2 also. මොනවාද මේ body language එක බෙදන්නේ? How do you subdivide body language? Anyone? වචන දෙකක් තියෙනවා, එක වගේ වචන දෙකක්. Posture, gestures, and facial impressions. What is my posture? So ඉරියව්. ඔයා හිට ගන්න විදිය, ඉඳ ගන්න විදිය. So then gestures, අංග චලන වගේ දේවල්. Then facial expressions. Muhune. Confidence, the නැද්ද, ලැජ්ජාශීලීද? So those are very important. So then what else? Voice control. Voice control. So good communication is not monotonic. Monotonic කියන්නේ ඔන්නෝම සමහර කතා කරද්දී monotonic. මම ඔයාලට උදාහරණයක් මම දෙන්න එක හොඳට දන්නේ. ඒ දවස්වල තාමත් යනවා. ටීවී එකේ යනවා ඒ දවස්වල මම දන්නේ මම පොඩි කාලේ ඉඳලා යනවා තාමත් යනවද දන්නේ නැහැ. මහජන බැංකුවෙන් යනවා මොකද දැනුමයි වාසනාවයි කියලා. ඒ දවස්වල මම තාම යනවද දන්නේ නැහැ. මම දැන් ටීවී බලන්නේ අපේ ගෙදර ටීවී එකක් නැහැ දැන් අවුරුදු 10කට තිස්සේ. 10කට වැඩි. ඒකට දැන් අපි ටීවී ඕනේ නැහැ නේ අපි ඉන්ටර්නෙට් තියෙන්නේ. මට මතකයි ඒ දවස්වල යනවා දැනුමයි වාසනාවයි කියලා. ඕකේ අර ප්‍රශ්න අහන්නේ ඔය අතරතුර හැමෝටම විනාඩි 2ක් විතර දෙනවා කතා කරන්න කියලා. 99ක් කටපාඩම් කරන් ආපු එකක් කියවනවා. කටපාඩම් කරන් ආපු එකක් කියවනවා කියලා කියන්න පුළුවන් හොඳම විදිය තමයි මොකද මොනොටොනික්. මොනොටොනික් කියන්නේ එයාගේ මෙලෝ හැංගීමක් නැහැ. හැංගීමක් නැතුව කටපාඩම් කරන් ආපු එක කියන්නේ. මම තව උදාහරණයක් කියන්නේ මම දන්නේ හොඳද නරකද කියලා. ගිය පාර පාර්ලිමේන්තුවේ හිටියා විශේෂඥ වෛද්‍යවරියක් සීතා කවුද කියලා. හරි සීතා කවුද කියලා. නිකන් YouTube එකට ගිහලා සර්ච් එකක් දාලා අහලා බලන්න. එකම අඬෝ වැඩි ආවා. මොනොටොනික්. ඒ කියන්නේ එයාට මෙලෝ හැංගීමක් නැහැ. එයාට අර කටපාඩම් කරගත්ත තියක් ඔහේ කියවනවා. හරියට අර ඉස්කෝලේ විවාද කණ්ඩායමේ පොඩි කෙල්ලෙක් වගේ. 10 පන්ති. මෙලෝ බරක් නැහැ ඒ වගේ. maturity එකක් නැහැ. But when you communicate with your feelings, emotions, seriousness, so there's a up and down. Sometimes you emphasize something, sometimes you are relaxed, sometimes you are a little bit aggressive because we are humans. Sometimes you are into a sort of a funny mood, but those monotonic mean you just memorize and vomit. So in the interviews also what we looking for is those natural people, genuine people, not භයංකර බෝඩික් වැඩක් නෑ අපිට. So those are part and parcel of good communication, right? Your postures, gestures, facial expressions, voice control. නේද? සමහර නිකන් බිල්ලෝ වගේ ඉන්නේ. කොහෙට හරි ගියාම. Gestures, postures upset. Postures upset. ෆොටෝ එකක් ගහුව ගමන් upset postures වදින්නේ. So that is a total package, right? So make sure you are talking relevant, simple, short, precise, accurate things. Make sure you carry your confidence, subject knowledge, skills that reflect your communication, because then you are a comfortable, confident person. And think about your language skills, verbal language skills, grammar, words, and don't forget about the non-verbal things, postures, gestures, facial expressions, voice control, and other aspects. So then it's as a total package, you will be an effective communicator, good communicator. Right? Simple as that. Okay, right. So I just gave you big overview about the communication skills subject. Okay, right. So we stop at this point. Thank you. So today we will not be doing web development. Okay, right. We stop at this point.
Thank you, sir.
Okay, you're welcome.